Alright folks, thanks for coming. Today we're going to give you many real world applications of quadratic equations, okay? Sometimes you can call it the quadratic models, alright? Just like we did in linear equations, quadratic equations has models. There are a lot of models from quadratic equations that you can use to solve real world problems, okay? So this kind of problems we're going to solve using quadratic equations. You see some of them in physics, you see some of them in calculus, but we're just going to use algebra, okay? We're going to use algebra to formulate the model and then solve the model, okay? Alright, but before we do that, I'm gonna introduce you to what is called Pythagorean Theorem, because we're gonna use some of it in solving real world problems, okay? Some of you probably know what that means. We'll learn it from before high school, but I'm just gonna explain it to you. That way when I use it, you know that I'm using it, okay? But anyway, before we start, subscribe to my channel, like and share this video. You have any questions or comments, leave it under this video. I will get to them. Alright, so what I'm gonna do, I introduce the Pythagorean Theorem. Then after that, I give you a couple of examples on it, and then we'll kick it out. We're gonna solve a lot of problems, so this video may be longer again, but we'll stay with it until we finish what we want to finish. Okay, let's deal with Pythagorean Theorem. Basically, it says in a right triangle. Pick up on that. What is a right triangle? A right triangle is a triangle that has, you see, they show it using something like this. It's a triangle that has one angle 90 degrees. This angle is 90 degrees, okay? Alright, and then if it's 90 degrees, this thing here is called the one leg. It's one leg here, right there, and this here is called another leg, okay? Okay, so they call it leg A and leg B, okay? Let me make sure you understand that. Let me clear it. Make sure you understand that. You gotta understand that the angle there has to be 90 degrees. Alright? If it's not 90 degrees, then this doesn't hold. This is leg A, and this is leg B. Okay? And then that is C right there. C is called hypotenuse. I can't draw very well, but it's a straight line. Hypotenuse, okay? This is a hypotenuse right there, is C. So make sure you understand that in a right triangle means this angle here has to be 90 degrees. That's what right triangle is usually called, right angled triangle. Sometimes you see, let me write it down. That way when you see it, you understand. It's called sometimes the right angled triangle, okay? So the same thing, okay? So in a right triangle, the sum of the squares of the legs are equal to the square of the hypotenuse. That's what is written there, okay? The sum of the squares, this is the square of this one, the square of this one, you sum it. The sum of the squares are equal to the square of the hypotenuse. Basically, you square this, you square this, you square that. They're saying when you add this and that, but the addition is equal to that. That's what that says here. So make sure you understand that. If you understand that, you use that a lot in solving problems, okay? So the important thing is this angle must be 90 degrees. And this is a leg, and this is a leg. Those two legs, then from those two legs you connect C. C connects two of them. Make sure you understand the setup. If you understand the setup, you won't have any problem, okay? Alright, So that's what the theory says. Let's we're gonna give you some example. By the way, let me tell you something. When you solve problem, here is general stuff you pay attention to. When you solve word problem, real world application problem, just read it. Well, let me write it. Solving application, okay? I write it like that. Application problems, okay? This is my idea, Okay, first read it carefully. You read it carefully. Notice what is knowing, notice what is unknowing. Okay? 1, read carefully. You gotta read carefully, man. Read with care. Whatever you wanna say, read carefully. Notice knowings and the unknowns, okay? Yeah, keep that in mind. See what is knowing, see what is, what they're looking for. Usually it's one unknown, or maybe in several unknowns, I don't know. And then 2, after you read that, read it carefully, make sure you understand it, and then you assign a variable, okay? Usually there's a variable involved. Assign a variable to unknown. Okay? See that unknown. I think usually there is one. Assign a variable to something that is not known. Okay? And then 3. Okay? 3. Form an equation, okay? Or the another way I can say it is design an equation. It doesn't matter. Design an equation, okay, using the variable we have up there. Okay, and then for solve the equation, okay? You solve the equation, you form that board. That's it. Once you solve it, then 5, you can say 5, interpret it. Interpret it, man, because it gotta be interpreted. Interpret your result, okay? Your result. That way somebody can understand it, okay? So read carefully, assign variable or variables if you need 2 variables. Design the equation, solve the equation, interpret your results. You can say if you want result or results, interpret it, okay? So what we're gonna do, I'm gonna give you an example on Pythagorean Theorem, and then from there we'll solve a bunch of problems, okay? Okay. Let me show you an example of using the Pythagorean theorem, okay? You remember the Pythagorean theorem says this is this thing here, this side is A, this side is B, and this side is C. Then it becomes A squared plus B squared is equals to C squared. You remember that, right? That's what we just discussed in the previous slide, yeah? Okay, this is A now, A. Okay, that's the Pythagorean theorem, okay? But here is the thing. In this, you will find a real life situation where you replace you replace A with X, you replace B with X plus 2, and you replace C with X plus 4. And then the idea is you use Pythagorean theorem to combine them and then solve for X, okay? There are different kinds of situations that may arise. That might be a situation where the problem you could be missing this one, and you giving this and that, okay? And then you're gonna use Pythagorean. You apply Pythagorean theorem to find the missing one, okay? There could be a situation where it doesn't have to be that leg. You could be missing this one here, and then you're gonna use the Pythagorean theorem to find that one, to find that this is if the hypotenuse is missing, okay? So there are different variations. You will see I have 2 examples to show you the situation that can arise, okay? All right. There might be situation where you have exactly this setup. a setup like this, you could have x plus 4 here, x plus 1 here, x plus plus maybe x minus something there. You have that setup. It's possible, and then you use Pythagorean theorem to find the value of x. Okay, so you just apply the Pythagorean theorem and then resolve the model. All right, so in this case, you see what we're given. So we're gonna use Pythagorean theorem. Let's use it to solve that. All right, so what do we know? We know that x squared plus x plus 2 squared is equals to x plus 4 squared. This is what the Pythagorean theorem said. Okay, now we'll start simplifying. Okay, so we say x squared plus x plus 2 times x plus 2, you see, equals to x plus 4 times x plus 4. Okay, so we'll try to multiply everything out. X squared is over here, then we'll multiply things out. X times x, you get x squared. X times 2, you get 2x. Now we'll start with 2. 2 times x, you get 2x. 2 times 2, you get 4. Is equals to x times x, you get x squared. X times 4, you get 4x, yeah? And then 4 times x, you get 4x. 4 times 4, you get 16, okay? So now we're going to simplify things. Recall that I told you whenever you have anything like this, you always want to put it in the standard form. The standard form is this thing here. Plus c equals to 0. You want to put it in this standard form and then you solve. So let's try to put that in the standard form first before we solve, okay? This is x squared plus x squared plus, what is that? 4x plus 4 is equals to x squared plus 8x plus 16. Okay, so we'll move stuff from the right hand side to the left side, okay? We'll have x squared plus x squared plus 4x plus 4 negative x squared negative 8x negative 16 is equals to 0. Okay, well, now we'll combine things, okay? This combines with that and that. What do you get? One of them will cancel out, so you get x squared. You get one of them. And then what is the other one? This one and that one will combine. We're combining like terms. And when you do that, what do you get there? Negative 8x will swallow positive 4x, and then what is remaining is negative 4x. You see that, right? And then we'll combine the constants. What is that? Again, negative 16 will swallow positive 4 to give us negative, what is that? Negative 12. The whole thing is equals to 0. You see that, right? Now it's up to us to solve that. You solve that. That's a quadratic equation. Once we reduce it here, it's a quadratic equation that we will recognize. You can solve it using any method. Remember that I discussed 3 methods and showed you example. The first method is factoring. The second method is using completing the square. The third method is using the quadratic formula. But I'm gonna use the first method, factoring. Remember this? We'll go like that. We'll put x here. We'll put x here. Now we need 2 numbers, so that when they multiply themselves, they get negative 12. Then when you add them, you get negative 4x. You see that, right? So what can those 2 numbers? I think 6. See, 6 and 6 and 2 are good candidates. You see that? If you multiply, let's put negative sign here. Multiply negative 6 times 2, you get negative 12. Then, but if you add them, what do you get? You get negative 4. So let me show you. If you doubt it, let's go this way. Let's come down this way. This is a way I'm doing to verify. Negative 6 times x, you get negative 6x, okay? And then 2 times x, you get 2x. what do you get? What do you get there? You get negative 4x. You see, that's what we're looking for. So we know that thing will work. We know that thing will work for sure. So we'll go like that, go like that. If you don't know what I'm doing, go watch my previous video. I saw many examples on that, okay? And then from there you say x, you gotta take the signs. Whatever sign that thing has, you take it. X minus 6 plus x plus 2, sorry. X minus 6, right? Times x plus 2, right there is equals to 0. You see that, right? And then you say x minus 6 equals to 0, or x plus 2 is equals to 0. You solve x equals to 6 or x equals to negative 2. Notice something. Notice that these are the length of this triangle. Notice that x plus 2 is the length, x is the length, x plus 4 is the length. So there's no way x can be negative, because let me see. Because if x is negative, then you're gonna have negative 2 here. You see that's impossible. The length cannot be a negative number. Okay, so basically what that is telling us, this solution is, I'm sorry, I don't want to wipe that out, man. X equals to negative what is that? Negative 2. Okay, it tells us this solution is not acceptable. The only solution we'll have is x equals to 6. You see, based on the situation, because we're looking for each side, the length of each side of the triangle. There's no way it would be negative. You can't have negative length. You understand? You cannot have a negative length. Just like you can't have a negative speed. Well, you can't have a negative distance. Yeah, you can have a negative speed. Speed can slow down. But you can't say you travel from your house to work is negative 2. It's impossible. There's no such concept, okay? Just think about that here. So this one doesn't work. This is the only solution we'll have, okay? Alright, so this example, just look at it carefully, cover it up and try to solve it yourself using Pythagorean Theorem. So make sure you understand it, you see. So I'm gonna show you another example. Okay, here is another example. This is a real world example. It says Chuck wants to cover the backyard of his house with cement. His backyard is exactly triangular in shape. One leg of the right triangular backyard is 2 meters shorter than the other leg. The backyard will have an area of 24 meters squared. Find the length of the legs. Okay, you see what is happening? So the diagram there even show you. See, these are the from what it says. Let me see. It says there's always a cue when you're reading this. It says his backyard is exactly triangular in shape. One leg of the right triangular backyard is 2 meters shorter than the other leg. 2 meters shorter. So if this is one leg is x, then the other one is 2 meters shorter. Okay, so basically the setup is there. Then they tell you it's 2 meters shorter than the other one. Okay, fine. Back here we'll have an area of that. Okay, okay, so you're given the length, you're given the area of a triangle. They want you to find the legs, okay? So we've done something like this before. It's not a big deal, So what you're gonna do, we read the problem carefully. So we need to find the legs, right? The 2 legs, right? Okay. Let me see. Let's. Of course, we know. The picture showed us let x be length of the shorter leg, right? But you can say one leg or the shorter leg, it doesn't matter. Then x minus 2 is the length of the longer leg, okay? No, this is the shorter. Hang on a minute. What does the problem say? You gotta read that carefully, man. You gotta read. What does it say? One of the leg of the right angular bracket is too shorter than the other leg. Okay, you're giving the one that is shorter than the other leg. So let S be the length of it. You can say the shorter leg. You see? No, the longer leg actually, because it's longer. You can say one leg or the longer leg, and then this is the length of the shorter leg. See? Because it's shorter. Shorter leg, okay? Yeah, because one is longer. One is 2 meters shorter than the other. So the longer one is, if the longer one is x, then the shorter one is x minus 2. You see that, right? So once you said that, then you have to write the equation. You know, if you look at the back of your book or look, they will give you the area of a triangle is like that. Half the base times the height, okay? All right, and then normally the base, the base is usually, let me see, the height. What I mean by the base, if you draw the triangle, right angle triangle right here, if this is the base, then this is the height. So one of them, you can choose whichever one you want, base and height, you see. So height base situation. So basically that means the area is equals to half of x times what is that, x minus 2, right? It said minus 2, yeah. So that's what that means. And we're given the area, that's the area right there. And then you're given 2 meters. Well, you already took care of that. The area is that. You got 24 is equals to half x times x minus 2. You see that, right? That's all. Once you set that up, you simplify. Okay? Simplify it. If you simplify that, multiply both sides with 2, you get 48 equals to x. Okay, like that. You can multiply the right hand side out. If you want, write it like this. Okay, hang on, let's multiply it out first. Let's multiply the right side out first. Multiply it out, what do you get? You get x squared minus 2x, okay? Alright, so you can move things over. You can say 0 equals to x squared minus 2x minus 48. You see that, right? And you can, of course, you can write it like this. You can also flip it around. Write it like x squared minus 2x. You're not changing anything. Minus 48 equals to 0. That way you can see it normal, the way we normally see it. So once you get this, then you're gonna use any method you like to use. One of those 3 methods to factor it. You can use the quadratic, what do you call that, quadratic formula, or you can use the factoring method, or you can use the, what do you call that, completing the square. But I'm gonna go ahead and use this. Or I put x here, put x here. Alright. So what are the 2 things that can give you 48? If you multiply them, you get 48. You gotta think hard and deep now. One thing come in mind. If you multiply 8 by, 8 by 6, 8 times 6 gives you 48, okay? So you multiply 8 by 6, you get 48. But we want to be able to get negative 48. So you can make any of them negative. So you want is making the one negative such that when you subtract them, you got negative 2. Look at that. If you do that, negative. You multiply negative 8 times 6, you get negative 48. Then if you add them, what do you get? You get negative 2. If you doubt it, multiply like that. Negative 8 times x, you get negative 8x. 6 times x, you get 6x. You add them, what do you get? You get negative 2x. You see that, right? Okay, so once you can see that, the rest of the problem are done. You just factor like that, x minus 8. Make sure you don't forget the minus sign. Okay, x plus 6 is equals to 0. You see that, right? Once you do that, you say x is equals to, I'm going too fast. Let's slow down. I'm jumping the gun, man. Sorry. X minus 8 equals to 0, or x plus 6 equals to 0, okay? You get x equals to 8, or x equals to negative 6. What are we looking for? We're looking for the length of the triangle. Yeah, we're looking for a length, right? So the negative won't correct, so we don't need that, because you can't have that negative, right? It's like having negative distance traveled. It's impossible. So 8 is what we're looking for. Once you get that 8, don't forget the word we started with. You can say then, this is the shorter. No, that's the longer, that's the shorter, right? Longer, shorter. So then if you get 8 equals, x equals to 8, then you can say longer is 8. What is that? 8 meter long. And then the shorter leg is 8 minus 2. And that's 6 meter. Okay? Alright, here is the third example. It says Rose and Mary left their college campus at the same time, with Rose heading north and Mary heading east. When Mary is 1 mile farther than Rose from the campus, the distance between them is 2 miles more than Rose's distance from the campus. Find their distances from the campus and the distance between them. Okay. Now you have to draw this stuff, that way you can have an idea what they're saying. Let's say this is the campus here, okay? And they say they left at the same time. Okay, with Rose heading north. So Rose is heading north this way. This is north, okay? Rose is heading north and Mary heading east. So this is east this way. See? You see that, right? This is east. Okay. Okay. You see that? So you can notice this is a right angle. You can connect them like that. So it forms a right angle triangle. Okay. Now let's see if we can figure out the rest of the stuff they're saying. Notice let's see what they say. It says when Mary is 1 mile further down Rose. What is that? When Mary is 1 mile further down Rose from the campus. Okay. When Mary is 1 mile further from the campus, the distance between them is 2 miles more than Rose's distance. So that's your Q right there. That's your Q right there. Find their distances from the campus. They're looking for their distances from the campus, okay? in let's say what is that? Rose is here. What does it say? Rose heading north. This is Rose and this is Mary. Okay. All right. Okay. When Mary is 1 mile further than Rose from the campus. Well, Mary is 1 mile further. So than Rose. So we're gonna say let X be Rose's, right? Let me see. Yeah, because it's further 1 mile further than Rose. Let Rose's be Rose's distance. Okay. Distance from campus. Okay. Okay. If that's the case, then it says when Mary is 1 mile further than Rose from the campus, then distance between them is 2 miles more than Rose's distance from the campus. So if that's the case, then this is Rose's distance from campus. If that's the case, then it said X plus 1 is Mary's distance from campus. Mary's distance. You see that, right? From campus, okay? Because you read that again, it says, when Mary is 1 mile further than Rose from the campus, okay? So if this is Rose's distance from campus, Mary is 1 mile further than that, okay? And then another relationship given, the distance between them is 2 miles more than Rose's distance from the campus. You see, Rose's distance comes from, so the distance between them, so this is then 1, then 2. The distance between them, what is it? The distance between them is 2 miles more than Rose's distance from campus. We got Rose's distance from campus, so distance between them will be X plus 2 will be distance between them. Okay, distance between them. This is how I write between B/W. You know what? Let me write it out. I don't want to confuse anybody. Distance between them. Okay. So basically, distance. Okay. Look at the map I drew, right? Look at the map. This is campus, and this is Mary. This is Rose. Distance between them is that. So if Rose is X, then Mary is X plus 1. The distance between them is X plus 2 right here. You see it, right? Because this is if this guy is here, then that guy is there. Okay. So having formed down, you see that that's what we're looking for. So based on what, from Pythagorean theory, so you're gonna say this squared, that squared is equals to, you add them is equals to that squared. So in other words, x squared plus x plus 1 squared is equals to x plus 2 squared. You see that, right? Did you want to solve something like that before? Did you want to solve something like that before? I think we did. You see that, right? Let me see, what was that we did up there? Let's go back and look. No, it's different. What did we do here? No, it's different. Okay, no problem. We can solve this one. No big deal. Okay. So that's the equation we formed. So we say x, we expand, plus x plus 1, x plus 1, multiply that like that, x plus 2, x plus 2, see? Okay, expand x. x times x, x squared, x times 1, x, 1 times x, another x, 1 times 1, another 1 is equals to, do the same thing, x times x, x squared, x times 2, 2x, 2 times x, 2x, 2 times 2, 4. You see that right where? Now don't forget, we're going to try to put it in this form. That's our target. B, x plus c equals to 0. That's the standard form. We'll have to put it in that form, so we'll simplify it. Alright. You see that, right? So let's simplify the left first and simplify the right before we move things. We say 2x squared, okay, plus 2x plus 1 is equals to x squared plus 4x plus 4. Okay, we'll move the right hand side to the left. We'll get 2x squared plus 2x plus 1 minus x squared minus 4x minus 4 equals to 0. And then we'll start combining the likes, like with likes. Okay, we get 2x that plus, so it's x squared. What is that? 2x and negative, it becomes negative 2x, negative 3 equals to 0. You see that, right? I combine everything. That's what you're gonna get. I hope you see that. I don't know if I made any mistake. I don't think so. You combine that, you get that. Now once you get to this point, standard form, use any method you want. You can use the formula, the quadratic formula. You can use completing the square. You can use factoring. I use factoring to x. Now you ask yourself, what two things will multiply to get negative 3? At least I can say 3 and 1, but one of them has to be negative. What do I want to make negative? Based on what right here, we'll make 3 negative, we'll make 1 positive, because if you multiply those two, you get minus 3. If you subtract them, you get minus 2. See here. So let's check. Let's go down this way. Negative 3 times x, negative 3x. X times 1 plus x. Add them, negative 2x. You see? That's what we're looking for here. So we got that right. We're just checking, man. So what is here? This is 1 here, don't forget. So we do like that. So I need more space. So I'm gonna go like that. Okay. So we have x negative 3 equals to 0, or x plus 1 equals to 0. Keep going. Says x equals to 3, or x equals to negative 1. Okay. Based on what we know, we're looking for distance. Right? We're looking for the x gotta be distance, so we know that this one will not work because it can't have negative distance. Okay, so the only solution we'll have is x equals to 3. Okay, so if that's the case, let me see. Rose's distance is 3. Rose got distance, okay. Distance is in mine. Yeah, that's distance. Distance from campus of Rose equals to 3 miles, okay. And then if that's the case, where is Mary's? Mary's is x plus 1. So Mary would be Mary's distance, okay. Distance from campus will be 4. And then what is this? It's a distance between them. Distance between them is plus 2, right? Distance between them. Okay, is 3 plus 2, which is 5 miles. This one is miles. Okay, so we're done with that, man. Alright. You see that, right? So we're done with that. We'll carry that there. Okay, here is our problem number 1. We're gonna try to solve a bunch of problems. It says the length of the hypotenuse of a right triangle is 2y, the length of the shortest leg plus 3 meters. Okay, the longer leg is 7 meters longer than the shorter leg. Find the length of the sides. Okay, find the length of the sides of the triangle. Okay, all right. Now, like I tell you, you always gotta take your cue from when they start comparing things. You see right here, it says the length of the hypotenuse of a right triangle is 2y, the length of the shorter side leg plus 3m. So you're comparing the hypotenuse to the shorter side. Okay, so that's your cue there. So you're gonna say let x be, okay, let x be the shorter side. Okay, the length of shorter leg. Okay, because you see the comparison there, and then they say the hypotenuse is 2y, the length of the shortest leg plus 3m. In other words, then the hypotenuse, no, wait a minute, the length of the hypotenuse is 2y, the length of the shorter leg plus that. Yes, that's what he's saying. So the length of the hypotenuse then is the length of the hypotenuse is going to be, say, 2 times the shorter, right? Is towards the length of the shorter leg plus 3 meter. So this is the hypotenuse. I'm sorry, this is the length of the hypotenuse. This is the hypotenuse right there. You see that, right? And then what else does it compare? The longer leg is 7 meters longer than the shorter side. Yeah, that one is easy. This is the shorter side, so the longer meter is plus 7. So this is the longer. This is the longer side, okay? The longer leg. Yeah, it's the leg, not the side. The longer leg, you see that? Okay, so you got all those 3 things. So if you would draw it, you say the hypotenuse is 2x plus 3, and the let's say the longer leg is, let's say this is the longer leg. Well, it doesn't matter which one we put where. This is, and then this is x. So by Pythagorean Theorem, we have x squared plus x plus 7 squared is equals to 2x plus 3 squared. You see that, right? So that's how we're gonna solve, man. So we expand it. We expand it and then put it in the standard form. See that? Times x plus 7 equals to 2x plus 3 times 2x plus 3. So we're expanding it now. We're not done expanding. Plus x times x squared, x times 7, 7x, 7 times x, another 7x, 7 times 7 is 49, right? Okay. Expand that is equals to 2x times 2x is 4x squared, 2x times 3 is 6x, 3 times 2x, another 6x, 3 times 3 is 9. See that, right? Alright, so we expanded everything. Let's try to simplify that before we move things over. Plus, this is 2x plus 14, 2x squared, sorry, plus 14x plus 49, right? Is equals to 4x squared plus 12x plus 9. Now we'll move the right hand side over to the left hand side. We'll get 2 plus 14x plus 49 negative 4x squared plus, no, negative. Because we're moving over from the other side to negative 9 is equals to 0. So we'll combine, okay? You combine that and that, you get, see what's going to happen. 2x squared will be absorbed. You get negative 2x squared, okay? And then you combine this and that, you get what? You get 2x. That's what is remaining. You combine this and then what do you get? You get plus 40, all equals to 0. But notice that in the standard form, we'll have to get rid of whatever is on x, the coefficient of x squared. Well, no, the standard form, sorry. The standard form is this. bx plus c equals to 0. Okay. That's the standard form. So, to put it in that form where this one is positive, we'll multiply everything with negative 1. We're not changing anything. So it becomes 2x squared negative 2x negative 40 equals to 0. Because you multiply 0 plus with the negative 1, you still get 0. What is all this motion? Just give me a minute, man. Give me 1 minute. Let me see. Alright. So, I think it's the wind. My camera was detecting some kind of motion, but there's nothing there. It's the wind. Alright. Okay, so we'll have to solve that. That's what we'll have to solve right there, okay? How you solve it is up to you. You can use the quadratic formula. You can use you can do completing the square, or you can factor like I showed you. That's what I'm gonna do. Is that one to me is easier to me. I mean, I can work with the other ones too, but this is a little much easier. So basically, if we eyeball this stuff, there's something we can do actually before we start factoring. Let me tell you something. It's up to you. I see something. We can divide the whole thing by 2. Then we'll get x squared minus x minus, what is that, 10? Not 10, 20. We'll get 20. We'll get 20 divided by the get 20 equals to 0, right? I don't know if we'll change it too much because I don't know how you're gonna factor that. Actually, no. Actually, no. Yeah, we can do it. We can do it. Sorry. Yeah, we can do it. What am I talking about? So, x times x squared, okay? And then look over here. You see, 5 times 4 is 20, right? But we need negative 20. Which one do you think we should make negative? When we're adding, we need negative 1 over here. I think it's this one like that. Let's do it. Okay. So let's multiply like that. X times negative 5, you get negative 5x. X times 4, you get 4x. If you add those things, what do you get? You get negative x. Okay, so that worked. You see that, right? So we take that like that. So our solution is, let's make more space. Our solution is x minus 5 times x plus 4 equals to 0, or x minus 5 equals to 0, or x plus 4 equals to 0. That's x equals to 5, or x equals to negative 4. Well, like I always said, the length of the side can never be negative, so this one won't work. This is the only solution we'll have. Okay, so once we get that solution, look at the stipulations here. So the shorter side, from there we'll see shorter leg. Shorter leg is 5, okay? What is that, 5, is that meter or inch? Yeah, 5 meter. Okay, from the stipulation to, okay, x plus 7 is the longer leg. So you say longer leg. 5 plus 7, right? X plus 7, yeah? Okay, that would be 12, right? That would be 12 meter. And then hypotenuse would be 2x plus 3. Hypotenuse 2x plus 3, that's 2 times 5 plus 3. So that's 10 plus 3 is 13. That would be 13 meter, right? Okay. You see that, right? We knocked 13 out. So we did a good job. Yeah, we did a good job there. We're done with that one. Okay, here's problem number 2. It says a lot is in the shape of a right triangle. The hypotenuse is 3 meter, longer than the longer than the longer leg. Okay, I see. The longer leg is 6 meter longer than twice the length of the shorter leg. Find the length of the size of the lot. You see what is going on there? So you always gotta pay attention to what they're saying, and you find your Q. Here is our Q here. Hypotenuse 3 meter longer than the longer leg, but we don't know what the longer leg is. We keep reading. He said the longer leg is 6 meter longer than twice the length of the shorter leg. Again, we don't know what the longer leg is. We don't know what the shorter leg. But notice, you gotta understand what is going on there. We've seen a lot of this in the past. The hypotenuse is expressed in terms of the longer leg. The longer leg is expressed in terms of the shorter leg. So we'll have to start from shorter leg. You see what I'm saying? Because both of the other sides are expressed both of them expressed in terms of the shorter leg. So we'll say let x be shorter leg, okay? Whatever, let that be shorter leg, okay? Or he can say the length of the shorter leg, whatever. Shorter leg. Okay? Based on that, they say hypotenuse is 3 meter longer than the longer leg. We can't say anything about that yet. You see what I'm saying? And then he said the longer leg is 6 meter longer than twice the length of the shorter leg. Twice the length of the shorter leg is that. And then he says the longer leg is 6 meter longer than twice. So 6 meter longer than means that. So this is the longer, okay? You see that, right? Make sure you understand what I'm saying. Longer leg. And then, if that's the longer leg, then what is the hypotenuse? He said hypotenuse is 3 meter longer than the longer leg. So then hypotenuse will be 2x plus 6 plus 3. You see that? 3 meter. That would be hypotenuse, okay? hypotenuse. You see that, right? You see that way, for you to not to go confused, then you combine them, okay? If you combine these, what do you get? You get 2x plus 9. It's still that the hypotenuse, okay? So based on this, we'll know what to do now, because according to Pythagoras Theorem, right? I can put it here. See, that somebody put that in there. This is the shorter leg over here, and then the longer leg, what is that? 2x plus 6, and the hypotenuse is 2x plus 9. If that helps you, but I really don't need that diagram. So what that means is x squared plus 2x plus 6 squared, okay, plus 2x plus 9 squared, okay? I'm sorry, what the hell is wrong with me? There's no plus here. It's equal to the hypotenuse. Sorry, this is equal to that. You see that, right? Yeah, these two squared added is equal to the hypotenuse. You see that, right? So now we'll have to solve for x. That's all. Once you set it up, the idea is to solve for x. Then you say x squared plus 2x plus 6 times 2x plus 6 equals to 2x plus 9 times 2x plus 9. You see that, right? So we expand. X squared plus 2x times 2x, you get 4x squared. 2x times 6, you get 12x. So we'll start with 6. 6x times 2x, you get 12x. You see that, right? Just go slowly, that way you don't make mistake. 12x. 6 times 6, you get what is that? 36, right? You see what I'm doing? I hope you can see what I'm doing. Just go slowly, think things through, don't rush. If you rush, you make mistake. Okay? Don't rush. Do it how comfortable do it at the speed which you're comfortable, okay? So that way you don't have problem. So let's do the right side. The right side is we say 2x times 2x, we get 4x squared. 2x times 9, we get 18x. 9 times 2x, we get 18x. And then 9 times 9. You see that, right? That's all you gotta do. See, that's all you gotta do. 9 times 9 is what? Is 9. What is that? 81. 9 times 9 is 81. You see that, right? Okay. So then we'll bring to put it in standard form. Don't forget the strategy. We need the standard form before we can do anything. So let's put it in standard form first. We'll say x squared plus 4x squared plus, we'll start combining things. Let's combine them. Plus 24x plus 36. Okay, we'll combine these two. Okay, let's combine before we bring over. It's 4x squared plus, what is that? That's 36, okay? Yeah, 36x plus 81. Then we'll move it over the other side. We'll get x squared plus 4x squared plus 24x plus 36, negative 4x squared, negative 36x, negative 81 is equals to 0. If we simplify that, we'll put it in standard form. Notice these go with that. We're going to combine those two. When you combine it, you get negative. Okay, and combine it with that too. You see that, right? Okay, don't leave that. And so these will cancel that. So we get x squared. Okay, 24. We're going to combine this with that. Okay, you see what's going to happen? 36 is going to absorb 24. You see that, right? And then we get negative, let me see, what is that, negative 12. Okay, we'll combine that with that now. What do you get? Okay, 36 will be absorbed by 81. You see that? You know, because 81 is negative, stronger. Okay, so you get negative 45. Alright, equal to 0. So it's in standard form now. So now we'll factor. Again, when you get here, there are 3 strategies to choose from. You can do factoring, the old-fashioned factoring, the one I usually like to do, or you can do completing the square. You don't like completing the square, you can use quadratic formula, but I'm gonna do what I normally do like that. I prefer this one. It's easier, quick. Okay, you notice the strategy this one involved with it. You gotta know the strategy. What is the strategy? The strategy is to find, we need to find 2 numbers such that, right, such that if we multiply those 2 numbers, they give you 45, negative 45. But if you add them, you get negative 12. Okay, what are the multiples of 45? We can say 9. We can use, I think 9, let me see. We can say 9 times 5. 9 times 5. 9 times 5 will give you 45. But if you add them, it doesn't matter which one is negative. If you add them, you're not going to get 12. So that won't work. You see what I'm doing, right? You can't use 9 and 5. What are for other multiples, right? What are the multiples of 45? Can you use, let me see. Let me see. What else can we do? One number can you multiply to give you 45? Let me see. Well, 6 times 7 will not do it. It won't give you 45. What of 15? Let's take 15. 15 times 15. That's too much. No, 15 times, let me see. 15 times 3. 15 times 3, what is that? That's 45, okay? 50, I think that will work, man. That will work. So that will work. I can tell you that will work. Now, let me tell you why. 15 and 3. Okay, which one do we need to be negative? I think 15 needs to be negative, man. You see? Because negative 15 times 3 gives you negative 45, right? But negative 15 plus 3 will give you negative 12. So let's see. So we'll put negative sign here. What the hell? So this is negative here and this is positive. You don't have to put the positive. We'll know it's there. Okay. And then this is x, this is x. Negative 15 times s, you get negative 15. X times 3, you get 3x. If you add them, what do you get? Add this. What do you get? You get negative 12x. That's what we're looking for. So we'll know we did it right. You know, so as long as you can find the multiples of that number there, find the multiples of this number. That you know, find the one that when you multiply they give you that number, and then when you add them they give you the middle number. Then you're ready to go. So we say this. We found the way we're looking for. So it's x negative 15 times x plus 3 will give you 0. Okay, you see it, right? That's what we're looking for. And then we say x negative 15 will give you 0, or x plus 3 will give you 0. Okay, we say x equals to 15 or x equals to negative 3. Now we're looking for a length of side of a triangle, so this won't work. There's something like negative length. It's similar to saying you drove negative 3 miles. That's impossible. So this is all we need. Okay, once we get that, what is that? That's the shorter leg now. You remember what we did here? Remember the conditions we put here? These are our condition right here. If that's the shorter leg, then what is the longer leg right there? The longer leg is 2x plus 6. Longer leg 2x plus 6, which is what is that? That's 30 plus 6. That's 36. You see that, right? Now, what is the hypotenuse? What is the hypotenuse based on our condition right there? 2x plus 9. 2x plus 9. This is equals to, what is that? It's 30 plus 9, okay? That's 39. And then we're done with this thing, man. We'll move on to the next one, man. That one is completely done with. Okay? Look at that. You say the triangular cell of a Schooner has an area of 30 meters squared. The height of the cell is 4 meters more than the base. Find the base of the cell. Okay, see, they even draw it there. This is the base here. This is the base here, okay? The base is here. And the height is here. And the area of that thing, they said is 30 meters, okay? So based on that, what can we say? Look at the condition they get. They say the height of the cell is 4 meters more than the base. 4 meters more than. See, they're comparing base and the height. So we'll say more than the base. So we're gonna start with the base. Let the base, let B be. Well, of course they already said it. Let B be the base, okay? They said it there. They gave it away. If the B is the base, they say the height of the cell is 4 more than the base. So then the height, based on the information given, the height is 4 more than the base. See, base plus 4, right? That's what that says. Base plus 4. Okay. Now we know the area of a triangle. The area, because this is a triangle. Notice that. This is a triangle. I'm not concerned about that thing they have at the middle. It means nothing to me. We use the area. Forget about that. The area of a triangle is given by this formula: half base times height. And then we're given the area, right? What is the area? We're given the area there. Okay, so we're given the area 30. 30 is half. Look at that. Base times height. We got B is the base, and then height is B plus 4. You see it, right? See? Remember I told you when we started that you don't necessarily have to work with X alone. X can be any value. X can be B. You can replace X with B. You can replace X with Y. You can replace X with W. That's what is going on here. So we simplify the right side. What do you get? You get half. Actually, let's be smart. Let's multiply both sides with 2. You get 60 is equals to B. You see that, right? Okay, so simplify the right side. You get B squared plus 4B. You see that, right? You see that, right? So we can move the 60 over there. 0 is equals to B squared plus 4B negative 60. You can rearrange it. Say B squared plus 4B negative 60 is equals to 0. You see that? That's the standard quadratic equation. Now we gotta solve it again. Once you get to this point, you choose whatever technique you like. I'm gonna stick with what I like. I know what I like. I don't know what you like. Whatever you like, you use. Okay, I'm gonna use this one here. Okay, b is here, b is here. Multiply that, you get b squared. Look at that, 4b. Okay, so what is it that we're looking for? We're looking for something. We're looking for something that we can multiply, give us 60. And then when we add it to, negative 60, when we add it to, we get 4. I think this one is easy. Look at 10 times 4. No, 10, yeah, 10 times 4 is, one of them gotta be negative. Let's say we'll put 4 here, put 10 here, make that negative. 10 times 4, no, not 4. Where am I getting 4 from? It's 10 times 6. It's 60, right? Okay, and then if you add 6 to 10, you get 4. That's how we get that 4 there. So if we down, let's do our magics. Negative 6 times b, you get negative 6b. And then b times 10, you get 10b. You add them, what do you get? You get, no. Yeah, it's correct. You get 4b. You see that? I thought the 4b is negative. No, you get positive 4b, so we're correct. Okay. So we know we're correct. So let's do our thing. We'll go like that, We'll say b minus 6 times b plus 10 is equals to 0. b minus 6 is equals to 0, or b plus 10 is equals to 0. b is equals to 6, or b is equals to negative 10. Again, from what we did before, it can't be negative because those are, the distance, the base is a distance, so it cannot be negative. There's no way you have something, the measurement of something, like measurement of your table, it can't be negative. So that one is cancelled out. So all we got is that. So based on that, that's the base now. Base is what is that? Base is 6. What do you think is the height based on our stipulation? Here is our stipulation here. Then the height is b plus 4. The height is b height. I can't spell today. Okay, height. Height is b plus 4. That's the same thing as 6 plus 4 equals to 10. Height is 10, okay? That's it, man. Height is 10, and then we're done with that. You see that, right? Yeah, height is 10. So we deal with that, and we're done with it. We're done with it, okay? Let's move on to the next one. Here is the next one. Here. What is that? It said the floor plan for a house is a rectangle with length 7 meters more than its width. Okay. The area is 170 meters. Find the width and the length. Okay, this is who does similar stuff like this. It's not it's like this thing we just did. You gotta find the formula. You know the formula. The formula, the area of a rectangular space is length times width. So, but let's use there's a Q here. It says length is 7 meters more than the width. So we'll start with the width then, because length is expressed in terms of the width. We'll say let's W. They already gave it to us here. Let W be the width, okay? Okay, and then we'll say this is the length is 7 more than the width. So that means the length The length is this. Okay, hang on. Let me make it a little cleaner. Length. That means length is W plus 7. That's all that means, man. That's all that means. So make sure you understand what it's saying. Make sure you understand what they're saying, man. Okay? You can even use the X. If you want, you can say let X be the width. So it doesn't matter what you use. We can use W or we can use that. You see what I'm saying? So if that's the case, remember what they say, the area is equals to length times width. So the area, they gave us area 170. 170 is equals to length times width. You see that, right? 170 is equals to, we got the width is W and the length is W. I'm sorry. So you gotta be careful how you write this. Remember, the length is W plus 7 and the width is still width. So basically that's what we need to solve right there. We're gonna put it in standard form. So let's deal with the right side. 170 is equals to what? W times W, you get W squared. W times 7, you get 7W. That's equals to 170. Okay, we take 170, the other side we get W squared plus 7W negative 170. Right, all that equals to 0. You see that, right? Okay. So basically that's what we got, man. That's what we got. We're gonna have to, this is a quadratic equation. We're gonna have to simplify. Actually, it's like the other problem we did. Look at it, eyeball it. What things can you multiply to give you 170? Two things you multiply and give you 170. Actually, negative 170. And then when you add them, you get 7. Think about 10. Because when I see 170, I look at 10. What is 10? 10 times, let's see right there. 10 times 17, yeah? It's 170. But we want to be able to get that. So which one are we going to make negative? We need to make this one negative. Because when you add them, you get 7. If you doubt, this is, I'm sorry. This over here is W here, W here. Because W times W will give you W squared. Okay, we'll give you that one. Okay, so if we say W times negative 10, you get negative 10W, okay? W times 17, you get 17W. If we add both, what do you get? You get let me see. You get 7W. See, that's what we're looking for here. Okay, so that worked. So always make sure you understand what we're doing. If you don't like this method, use other method. There are 2 other methods for you to select from. So since we'll find out, we'll go like that. And then it becomes W negative 10 times W plus 17 is equals to 0, okay? Alright? I'm getting out of control with my bracket. So that would be W negative 10 equals to 0, or W plus 17 equals to 0. W is equals to 10, or W is equals to negative 17. You see that, right? Okay. This won't work because there's no way length and width can be negative. It's impossible. When you find out how you can see a width or length that is negative, let me know. So all we got is that. Okay. Now based on what we know, look at that. So that's W, the width is that. So the length is, based on the condition we created above, the length is W plus, what is that? W plus 7. Okay, W plus 7 is what? Is 10 plus 7. It's interesting, 17. Okay, so we're done, man. That's what we're looking for, man. We're done with that, man. You see that, right? We're done. Okay, here is problem number 5. It says the length of a rectangular flower bed is 3 feet less than 2 wires its width. The area of the bed is 54 foot squared. Find the dimensions of the flower bed. Okay, it's similar to what we did before. So basically what you said there is, we know that length times width, right? Length times width is the area, okay? Okay, they gave us it's a rectangular, so it's length and width. Okay, let's say x. See, they gave us x up there. Let's say, well, first of all, see the comparison they're doing. The length is 3 feet less than 2 wires its width. So they put the length in terms of the width. So we'll say let x, since they're using x, we use x. Let x be the width, okay? Let x be the width. Then it says the length is 3 feet less than 2 wires. This is towards the width. 3 feet less. I'm sorry, 3 feet less will be 3 feet less will be 3 less, you see? So this is the length. You see that, right? Okay. That's the length there. I don't know how to spell length anymore. You see how I'm spelling length? I've been doing that for a while. Length is like that. TH ends it. Just like TH ends that one. Okay. But anyway, so that's what you got there. The area of a rectangular space is length times width. So we got the length here and the width here. So the area is equals to x times 2x minus 3. And they give us area. Area is that. So we'll say 54 is equals to x times 2x minus 3. That's all. So let's deal with the right. X times 2x, you get 2, sorry. We don't want to do it that way. You get 2x squared. X times 3, negative 3, you get negative 3x. You see that, right? Okay. So we can move 54 the other side. We say 0 is equals to 2x squared negative 3x negative 54. You can move things, flip things over. You get 2x squared negative 3x 54 is equals to 0. Now we'll have to factor that. You see that, right? We're gonna factor that. Now look at that carefully. Look at that carefully. Actually, not yet. Don't we have to get, what did I do? Hang on a minute. Is there a mistake? 2x squared 3. Okay. Let me see. So you multiply it then. Negative 3. Okay, fine. So what is going on? So we can actually, yeah, that's enough of them though. So we can say, you can use whatever you want to factor it, okay? I'm going to use what I like. So we have done something like this before. It's 2x over here, x. 2x times x gets you 2x squared. So we took care of that. Now, what can you multiply what two numbers can you multiply to get 54? Okay, that's the problem we have now. If we get the magic number, and then we're home free. So this is the place you give it thought. Okay, you gotta give it thought right there. Okay. So 54 got a bunch of multiples. Okay. At least I can think about one. 54 divided by 2, you get 27. So can we use 27 times 2? Of course, if you do this negative, let me see, do this negative, you get 27 times, negative 27 times 2, you get negative 54. But if you add those, will you get that? No. So that won't work. Find two other numbers that can multiply to give you 54. I think the next possible number is try 9. Actually, no, I made a mistake because I didn't take it. You see, when you have these two here, you gotta be careful. You know, you're not just looking for two numbers, looking for two numbers so that when you put that into consideration, this here, oh, I'm sorry. When you put 2x into consideration, you gotta put that into consideration. You know, so, but anyway, I know that, let me see. 9 times 6 will give you 54. See that, right? If we add 9 and 6, what do you get? If you add 9 and 6, yeah, that will work. But check this out, though. You have to be very careful. Let's say we do, okay, negative 9 times, see, be careful with this, negative 9 times 6. What would you get? You get 54, right? Negative 54. If you add both of them, what would you get? You get negative 3. You know, sometimes problems like this, sometimes you can solve it like this. We know those two things will give us that and give us that. Okay, so you don't really, okay, let's cross multiply and see. If we cross multiply in this case, you get 12x, and then you cross multiply over here, you get 9x, okay? Negative 9x. Add that, you get negative, let's see, you get negative 3. But you see, it will still work. Our strategy will still work. We just switch the numbers. Put 6 here, put negative 9 here. You see that, right? So, we're in good shape. Check that out. If you multiply positive 6 and negative 9, you get negative 54. But suppose oh man, oh Lord, what am I doing? Suppose you go like this, like we normally do. You multiply 6 times x, you get 6x. Multiply negative, okay, that will be 18. Actually, that will be 18, so it won't work. You gotta switch it the other way. You have to switch it the other way. Just give me a minute. You gotta switch it negative 9, 6. Yeah, you gotta switch it that way, yes. Because if you do the other way, you're gonna get negative 18x and positive 12x, and when you subtract, what do you get? When you add those two things, what do you get? You get negative 6x. That's not what we're looking for. But if you put it this way, it will work. I hope you see what I'm doing, right? You put it that way, it will work, because if you multiply negative 9 times x, you get negative 9x. 6 times 2, you get 2x, you get 12x. You add them, what do you get? You get Actually, no. I take it back. You see the problem with this? You can run into a problem like this. You gotta be careful, but you have to make sure you get it right. So remove that negative there. We'll have to put it here. We'll have to put the negative here, okay? So then, if you multiply 9 times x, you get 9x. You multiply negative 6 times 2x, you get negative 12x. When you add those two, you get negative 3. You see that 3x? That's what we're looking for here. Okay, so you always, if you don't do it right, you get the wrong answer. Okay? So you gotta play around with it until you get it right. That's the problem when you have, when the coefficient there is not, it's not 1. It can cause a little problem, but try and error, you find it. So we'll solve it like that. So it's 2x plus 9 times x negative 6 is equals to 0. You see that, right? Okay. Alright. So it's 2x plus 9 equals to 0, or x minus 6 equals to 0. Okay. So it will be 2x equals to negative 9. See, that one won't work. And then they say x equals to negative 9 over 2. So you can forget that one. Or equals to x equals to 6. Or x equals to 6. This one will work. This one it won't work. Because we're looking for a length. A length can be negative. You see? So that's what we're looking for there. So once you get that, look at our stipulation here. X is the width, 2x minus 3 is the length. So width is 6. Length is, what is that? 2x minus 3. 2x minus 3, which will give you 12 minus 3. What is that? 9. Yeah, that's the length right there. So we're done with that one. We'll move on, man. We'll move on to the next one. Okay. Okay, let's read that. The next one says, a carpenter needs to cut a brace to support a wall stud, as shown in the figure. The brace should be 7 feet less than 3 times the length of the stud. Okay, so that's the brace right there. That's that piece there is the brace. Okay. Well, and that's the wall there. That's the wall. See, this piece here is the wall. This piece here is the wall, okay? Okay. The brace should be 7 feet less than 3 times the length of the stud, okay? If the brace will be anchored on the floor, 15 feet away from the stud. Okay, that's wall stud, yeah. Okay, that is stud right there. Away from. How long should be the brace? Okay. Okay, so if you look at it carefully, I hope, see, that's why sometimes the picture is good. They call this wall stud. This structure here is wall stud. And they say this is the brace right there. The brace is 15 foot to the stud. Okay? And they say the brace should be 7 foot less than 3 times the length of the stud. The length of the stud is here. Okay, see what they did here. This is a right angle triangle. So we're dealing with Pythagorean Theorem. You see that, right? So because if we put all that stuff they're saying together, you're given this leg of the Pythagorean triangle. You said the brace should be 7 feet less than, and they gave you the brace. Okay. How long should be the brace? Okay, so you say if the brace will be anchored at 3 feet. So how long should be the brace? See, they want this fit. Okay. Well, how long should be the brace? They want how long should this be? But based on what we know, we have, you say the brace should be 2. Okay, they also compare the brace with 3 times the length of the stud with this length here. They compared this with this and they gave us that. Right? Okay, so from there we can formulate an equation, solve it with Pythagorean theorem, okay? So that's all that is saying. Whenever you see them compare things, pay attention there. That's your cue there. Okay, they said the brace should be 7 feet less than 3 times the length of the stud. So we need to let x be length of stud, okay? Because you see that comparison gives it away. Okay, let that be length of stud. Don't forget the length of stud is one leg of the triangle. That's right there. Okay, so that's x. X is right here. Okay, then see, he said the brace should be 7 feet less than 3 times the length of the stud. So 3 times the length of the stud is that. The brace should be 7 foot less. Subtract 7. So this is the length of the brace, okay? You see that, right? So we got this, we got that, and they want to know how long should be the brace. The brace is x. How long should be the brace? Yeah. No, well, we don't actually have the value of that, but we got it in an expression like that. And we got that, value here. So we'll put all that together. We're using Pythagorean Theorem. We should be able to solve it. I hope you see that. So basically, from the situation there, we'll have, let me see, x is there. This is let me see. You see, look at where the what do you call that? The 90 degrees is. 90 degrees is between the two legs of the Pythagorean Theorem, okay? So we'll have x squared plus, let me see, plus, hang on a minute. Oh, we got 15, sorry. Plus 15 squared equals to, this is the hypotenuse, equals to 3x minus 7 squared. You see that, right? Make sure you understand that. It took me a while to figure that shit out, but if you think it through, you see. Let me explain it again. That way you don't think I'm doing magic. See, they say that's the brace right there. That's the brace right there. And the brace is expressing, if they compared it to the length, what is that called? 3 times the length of the stud. They compared it to this. And we'll say let this be x, and then from comparison we'll get that, which is this here, and then we'll have this, and we'll know these are right angle. This is right angle there. Based on the Pythagorean theorem, we'll form this equation, and then we'll have to simplify x squared plus. You see that, right? I'm not doing anything. I'm not breaking any rule. I'm doing it according to what they said there. Okay? Okay, so this is 225 is equals to, check this out, 3x minus 7 times 3x minus 7. Okay, you gotta work that out. Okay, and then we'll have 3x times 3x, you get 9x squared. 3x times negative 7, you get negative 21x. Negative 7 times 3x, you get negative 21x. Negative 7 times negative 7, you get positive 49. You see that, right? Okay, so we'll simplify things on the right hand side. Simplify it up a little bit, we get 9x squared negative, what is that, 42? 42x plus 49. We'll move things around, okay? 0 is equals to 9x squared negative 42x plus 49 negative x squared negative 225. 225, okay? So simplify, what do you get? These and that take care of themselves, and these and that, okay? So what do you get? You get 8x squared and negative 42x. You have negative 176, okay? Okay, so you can move things, move 0 to the right side and move the rest of the stuff to the left. Nothing changes. 8x, negative 42x, negative 176 is equals to 0. So we gotta factor. So you can factor this using it any way you want. It's up to you any way you want to factor it, okay? Choose whichever method you like to factor it with. But I'm gonna use the method that, no, let me see. Actually, there's something we can do. We can do something first, because don't forget 0 is over here. Okay. What is that? 8, 22, and then you see what I'm saying, right? Okay. Check this out. Here's what we can do. We can divide all sides with 2. You get 4x squared negative, what is that? If you divide 42 with 2, what do you get? You get 21x negative. Divide that by 2, what do you get? You see what I'm doing, right? So we can reduce it. We don't care. Reduce it. And then if you divide that by 0, it still gets 0, okay? What else can we do there? Alright, we can use any method we would like to factor this thing. But I'm going to use the same method I've been using. Alright, so I'm going to use this method. Basically, we'll concentrate on 88. We need 2 numbers, okay? We need factors of 88. I think I can think of 4, let me see, 2 and 44, or maybe 4 and 22, 8 and 11, okay? And realize that we'll have this here. We'll have it like this over here on this side. So that will help you to visualize, because if you divide this, it divides into that. If you multiply them, you get that. Okay, so look at 22, look at the first one. It doesn't matter where. If we put 2 here, we'll get 8. Well, if we put negative 2 times 44 is negative 88. If we put 2 here and multiply that with 4x, what do we get? We get 8x. It's not gonna work. Okay, that won't work. So we'll forget about that one. Even if we put 44 here, even if we put negative 2 here and 44 here, it's still not gonna work. Alright? You see that, right? Because we're working with a higher number. Alright? So that one won't work. Because realize that 44 here, negative 2 here what's gonna happen is we're gonna get 44 minus what is that, minus 8. It's not gonna work, so forget about that one. So that one won't work. We'll just leave it out of it. Okay, what are 4 and 22? Okay, let's say we'll put let's say we have negative 4. We'll call it negative 4 times 22 will give you negative 88. We'll have negative 4 there, 22 here. You have 22x plus what is that? 4 times that is 16. Negative 16x actually. Alright. Would that work? No, it won't work. So even if you switch the number around, let me see. Even if you switch the numbers around, let's say you put negative 4 here and you put 22 here, it still won't work because you're dealing with a higher number now. So that one won't work, man. I know for sure it won't work. So you forget about that one. Now what of 8 and 11? You put 8 here, you put 11 here. Okay, which one you want a negative? Let's negative that. It's negative 8 and then negative 44. It won't work. Alright. So let's switch to negative. Even if you switch to negative, it still won't work because that would be negative 44. So I think what will work, switch it around. Let's try the other way. Suppose we'll put 11 here. Suppose we'll put 11 here, right? 11 here and 8 here. Which one should we make negative? Let's make this let me see. No, actually, let's make this negative and this one positive. What is 8 times 4? You see where I'm going now, right? So that will help you. This is how you're supposed to do it. If you start having difficulty, you just find the factors. Find the factors of that and then do trial and error until you find the one that will work. That's all. You see what I'm saying? Okay. So if you multiply negative 8 times 4x, you get negative 32x. And then multiply 11 times x, you get 11x. If you add them, what do you get? You see that, right? You see that, right? So I think that will work. Yep, you get negative 21x. So that's what we need right there. You see it, right? Okay. So that's what we'll need. Once we find it, we'll go like this. Don't let that confuse you. Let me remove that. And then we'll go like that. Okay, so that means 4x plus 11 times x minus 8 is equals to 0, okay? So 4x plus 11 is equals to 0, or x minus 8 is equals to 0. So 4x is equals to negative 11. X is equals to negative, what is that? Negative 11 over 4. Okay, or x equals to 8. Now, don't you gotta keep your eye on the ball. We're looking for length, right? Remember, x be length of stud. So length cannot be negative. So you forget about that one. It won't work. The only thing that will work is that. So the length of the stud has to be 8. The length of the brace has to be 3x minus 7. Okay. A brace. Okay. Brace will have to be, what is that? 3x minus 7. Let me make sure. 3x, yeah, minus 7 length of a brace. Okay. So we got x there. So that means 3 times 8 minus 7. What is that? You see where I'm going, right? That's what we're supposed to do. That's how you do it. So that's 24 minus 7. What is that? That's hang on a minute. Minus 7. That's 17. 7. I think it's feet. This one is feet, right? So it's 17 feet. So that's the answer right there. And then we're done with that one. Okay, that's the answer we're looking for. Okay, here is our problem number 7. I'm gonna read it now. It says the length of a rectangular rug is 6 feet more than the width. 6 feet. It says, actually they show it there. The length is 6 feet more than the width. The area is 40 feet squared. Find the length and the width of the rug. Now, see, you always learn, the more problems you do, the more you learn from the problem, okay? I've always told you to notice what they're comparing. When you want to find the variable you want to use first, notice what they're comparing. Look at what it says. The length of a rectangular rug is 6 feet more than the width. See, that's your cue right there. The length is 6 feet more than the feet. So you see, they give it away here and there. So if you say sorry, you can. I don't want to write with I don't want to write with red. Let me show you what I'm talking about. If you say let x be, because you said the length is 6 feet more than the width, so you gotta start with the width. Because if you let x be width, right, and then they said the length is 6 feet more than the width, so you have to add 6 feet to to the width. Let x be the width, okay? See, that's the idea. Then if we said that, then you say, because since they say length is 6 feet more than the width, then you're gonna say then x plus 6 is the length. You see that, right? That's the idea, man. So whenever they're comparing stuff like that, see what they're comparing to. 6 feet more than the width. So you gotta start with the width and then add 6 feet to the width. That's all. They even give it away there. They give you away there. See, So once you do that, another thing you need to know, they're talking about the area. We have done this before. The area of a rectangle. There's a formula for area of a rectangle. Is area of a rectangle is length times width. Okay, and you see, you are given the value of the area, and you have length and width in variables. So what you then say, what is that, 40, right? You then say 40 is equals to length, which is that, and width, you multiply with width, which is x. That's all. And then you take care of the right side. You have 40 equals to x times x, you get x squared. X times 6, you get 6x. You see that, right? So see, now we end up with the quadratic equation. So we can move 40 over the other side. We'll have 0 equals to x plus 6x minus 40. You can rearrange stuff. You can flip it. Put 0 the other side and bring the rest of the stuff on the left side. You're not changing anything. So you have x squared plus 6x negative 40 is equals to 0. I hope you understand that. I didn't change anything. I just flipped it around. That's all. That way I can have what I'm solving on the left. Actually, that way I can put it in the standard form of the quadratic equation. That's the standard form there. All right. Okay, so once you arrive at this situation here, like I always said, factor it any way you like. There are many ways you can factor it. You can factor using the multiplication method, that this thing here, or you can factor it using what do you call that, completing the square, or you can use the quadratic equation. Okay, I like to use this because it's easy to remember and easy to execute. Okay, all right, look at 40. We'll start with the 40 right there, and we'll ask ourselves, right, what are the multiples of 40? You got 2 times 20 multiple. You got what else? You got 4 times what is that, 4 times 10. These are the ones that are obvious, you see. Okay, so you want to be able to, you multiply these two. Well, one of them has to be negative. If you multiply them, you get negative 40. If you add them, you get plus 6. These two cannot do it, because it doesn't matter how you, if you put negative here or positive or negative on the other side, it doesn't matter. Both of them won't get you. If you add them, you won't get plus 6. But look at that carefully. You can tell, if you subtract 4 from 10, you get 6, right? So let's do this one negative. You see that? I mean, this stuff is you just have to be careful and look at it careful. If you put x here, put negative 4 here, put 10 here. Negative 4 times 10. Negative 4 times 10 is negative 40. See? And then negative 4 plus 10 is plus 6. If you that, you can cross check. Negative 4 times that, you get negative 4x. Okay, x right here times that, you get 10x. Then you add both of them. If you add both of them, what you get 6x. See? So that would do it. You know, we know that would do it. So we're done with that problem. Basically, we'll have to move on. So there's not, you need to split. Don't split hair. You find it, you move on. Okay, so it's like that. All right, so we say x negative 4 times x plus 10 is equals to 0. Okay, and then you say x negative 4 is equals to 0, or x plus 10 is equals to 0. X is equals to 4, or x is equals to negative 10. Now notice what we're looking for. We're looking for length and width. So obviously you cannot have a negative width or a negative length. So that one won't work. So this is our solution there. Okay, now remember our initial definitions. These are our initial definitions. So we'll have to say the width. Depending on what your teacher wants you to do, the width is 4 feet, okay? And the length is, what is that? What do we say up here? X plus 6. The length is x plus 6. See, the same thing as 4 plus 6. That's the same thing as 10, you see? 10 feet is the length, okay? And we're done with this one. Here is our next problem. I'm going to read it. It says that a treasure chest from a sunken gallon. What is that galleon? Has dimensions in feet as shown in the figure. Its surface area is 650 feet squared. Find its weight. Okay, so alright, so we're gonna have, you see, this is almost the same thing we did before. The surface area, they will give you the formula for the surface area. The surface area of something like this with it has length, and then it has width, and then it has depth. So usually they will give you the surface area. It actually has a length, height. There's a height, and the height. It's a box. It's a box. So you're gonna have to, I'll show you in a minute. But you see, the picture gave it away. The surface area is that. So the trick is to find the surface area. They give you the height. The height is x plus 4. The width is x. The length is 20. Okay. So I know that the surface area of a box like that is like this. Surface area. Well, the surface area, right? Surface area is equals to. They will give you the formula. It's 2 times width, because there are two of them. There are 2 times width and the height, okay, plus 2 times width and length, plus 2 times length and height. This formula will be given to you, so I wouldn't worry about that, because they don't expect you to remember all that. So what you're gonna do, you know which one is which. Okay, you gotta know which one is which. This is the height here. This is the height. This is the height, and this is the width, and this we say this is the length. Okay. So once you get that figured out, and then they give you the surface area right there, you say 650 is equals to 2 times, what is the width, x, what is the height, x plus 4. You see that, plus 2 times again the width, x, the length 20. You see what I'm doing, right? 2 times the length again 20 times the height, x plus 4. So once you get out that pudding, then you start solving, man. That's all. You start solving this thing. You start simplifying and solving it. That's all. That's all they want you to do. So I'm gonna shift to the left a little bit. 650 is equals to, now you multiply the right hand side out. What is that you got there? Let's put it in a way that would not make a mistake. You say 2x times x plus 4 plus 2x times 20, okay? Plus 2x, what is that? It's not actually 2x, it's 40, sorry. Okay. That's 40, right? 2 times 20 is 40. 40 times x plus 4. You see that, right? Let's cross check. 2x times that, 2x times that, and then 40 times that. So we'll continue simplifying. It's equals to, now we'll multiply across. 2x times s, you get 2x squared. 2x times 4, you get, what is that, 8x. You continue. 2x times 20, you get 40x. 40 times x, you get 40x. Alright? Okay, making sure we did everything right. And then 40 times 4, what is that? You get 160, right? Yep. 40 times 4 is 160. Alright, you continue to simplify. You got 650 equals to, now you gotta add the like stuff. 2x has no like, so it's 2x squared. Well, 2x squared has no like. Nothing is like that, so you leave it alone. You add this, add that, add that. You see that, right? So you add those, let me see, 80x plus 8x. So it's basically 88x plus 160. Okay, so you say 0, move the 650 to the other side. You got 2x squared plus 88x plus 160 minus 650. See that, right? What is that? Do that. If you do that, what do you get? Negative 490. Alright, okay. So let's rewrite that. We can move this stuff to the other side and move 0 to the right side. So we got 2x squared plus 88x negative 490 is equals to 0. You see that, right? Okay. I hope you're seeing that. Okay. Now notice something. We've done this before. We can divide everything by 2. It's not going to hurt anything. We divide everything by 2, we get x squared plus, what is that, 44 x minus, what is divide that by 2, right? What do you get? You get 245. You see that, right? Equals to 0. Okay, you see, basically that's what we'll have to deal with now. Again, use whatever. Now we'll have to factor it. Factoring it, you can use whatever method. You can use this the square root formula. You can use completing the square, or you can just factor it using stuff like that. But this one is a little high numbers, so we need factors of this. So when we get the factors, one is such that 2 of them multiplied will give us negative 245, and then 2 of them added together will give us positive 44x. So what numbers do you think we'll have to use, man? Okay, here are the factors of you see the factors of 245. Look at them. If you put negative in any of them, by the way, this is simple, x here, x here. You put negative in any of them, on one thing you get that, and when you multiply them you get negative 245, right? But to eyeball them, which one do you think will give you when you add things? Look at that. Okay, now notice that the first one will not work. It doesn't matter where you put the negative number, it won't work. And notice that the third one, let's look at the third one. The third one also will not work. It doesn't matter where you put, it doesn't matter where you put the negative. But look at the second one, and notice that one will work. So we can put 5 there, 49 there. But we'll have to make it that way. When you multiply them, you get negative 245. And then notice that is positive. So we'll put it here. We'll put negative there. Let me write it the way it makes sense. We'll put negative 5 here. Why? Watch this. Because when you multiply them, multiply this and that, you get that. Okay, but when you add them, you get that. You see that, right? If you don't see it, let me show you. X times negative 5x, you get negative 5x here. X times 49, you get 49x. If you add those two, what do you get? You get 44x. You see it, right? So that's why we have to do it like that. So basically, once we find it, we'll move on and solve the problem, okay? And then we'll say this and that, okay? This and that, and then we'll say this and that, okay? So we'll have x minus 5 times x plus 49 is equals to 0. X minus 5 equals to 0, or x plus 49 equals to 0. X equals to 5, or x equals to negative 49. We know this one won't work because remember we're looking for length and width and height. You can't have negative length or width and height. You see that, right? So automatically we know that one won't work. So this is the solution we're looking for. If you see what is going on, you see it has been defined for us here. So since I'm running out of space there, let me take up space. Let me take up space here, okay? So x equals to 5 is, what is that? Is the width. We got the length. They gave us length as 20, okay? And then what is height is x plus 4. Height is equals to x plus 4, and that's 5 plus 4, which is what? Which is 9. So we're done with the problem, okay? That's it. You know, those are in feet, and feet, okay? Okay, so we're done with that one. We'll move on to the next one, okay? Okay, here is the next example. It says that a pyramid has a rectangular base with a length that is 2 meters more than its width. The height of the pyramid is 6 meters, and its volume is 48 meters cubed. Find the length and the width of the base. Okay. Basically, we were dealing with height. Find the length and the width. Okay. So don't forget, rectangular base means that it's a rectangle at the base. So we're looking for the length and width of the base. So basically, we're concerned with the rectangle, okay? And all the stuff you need is already given to you there. Because he said the length is 2 meters more than the width, right there. This is the length and this is the width. And the volume is that. So, like I always say, they will give you the volume of a pyramid, okay? You don't have to worry about that. They're going to give you the formula for the volume. Alright? And note that the area, well, you know the area of the base. The base is a rectangle, so we'll know the area. Let me see what they say. The height of the pyramid is this, and its volume is that. Find the length and width. Okay. Well, based on what is given to us, we have that. We'll have that. We'll know that the area, let me see, the area of the base, we'll know that the area of the base is area of a rectangle. So, area of base, okay, equals to area of a rectangle, okay? That's what is given us. So that area is area of the base, okay? It's equals to, based on what we're given, x times x plus 2. Because area of a rectangle is length times width, okay? We know that because we did that before. Okay, the volume of a pyramid is like this: 1/3 b and times h, where h is the height, b is the base. Okay. Basically, b is the area of the base. I'm sorry. This is area of base. Okay, area of base. Okay, times the height. It's like that. And we're given the volume here. So we are given 48. 48 is equals to 1/3. Okay. Times, what is that? Times x plus 2. Alright. Times height is 6, right? Times 6. See? That's what we're given. That's what we're gonna solve. We'll solve that one on pre. Alright, so notice that I can simplify the right hand side. 48 is equals to, I get rid of 1/3. You get x times x plus 2. Divide 6 with 3, you get 2. Right there, see? 48 equals to x times x is x squared, x times 2 is plus 2x, and then you do that too. And then what is that? 2 times x squared, you get 2x squared plus 4x. See it, right? Alright. Okay. So you want to make it like it's, put it in standard form. You have 0 equals to 2x squared plus 4x minus 48. You see that, right? So you can run, first of all, let's rewrite it. We'll have 2x squared plus 4x minus 48 is equals to 0. Divide everything with 2, you get x squared plus 2x minus, what is that, 24 is equals to 0. See that, right? Now, this is standard form. Solve it any way you like. Use quadratic formula, use, you can complete the square, but I'm going to use this. Use whatever you like. Put x here. Now, what are the factors of 24? When you multiply that, it gives you plus 2. That's all we're looking for now. So we'll have, what are the factors of 24? We'll have 2 times 12, right? That won't work, because I don't see how, even if you make this negative, I don't see, even if you make the other one negative, it won't work. Okay. What are the other factors of 24? What is that, 3? You do 3 times something. 3 times 8. Right? 3 times 8 will give you 24. Okay, if you make one, look at 3 and 8. If you make 3 negative, you get negative 24, but if you add it, you get positive 5. It won't work. So, okay, try 4 times 6. If you make, yeah, it will work. Make that negative, you get that. When you add those two, what you get? You get positive 2. So negative 4, 6 will work. Negative 4 times x, you get negative 4x. Okay, plus negative 6. I'm sorry, 6 times x, you get 6x. If you add those, what do you get? You get 2x. So that will work. So it's like clear that we don't need that. That's not part of our, we're just checking. Okay. So since we figured it out, we said that. We say x minus 4 plus, what is that? X plus 6 equals to 0, okay? X equal, I'm sorry, x minus 4, okay? X minus 4 equals to 0, or x plus 6 equals to 0. X equals to 4, or x equals to minus 6. Well, see, we're looking for length. We're concerned with length of a rectangle, so there's no way length can be, you always cross the one that don't make sense. Length can be negative, so this is our solution there. What do they want us to find the length and the width. So what we just found is this is the width, that's the length. You see that, right? So the length, so width is 4. What is that? 4 feet, right? Let me see. Here width is the 4 meter. And then length is x plus 2. It's not in feet, it's in meter. Okay. And then length is, it was x plus 2, which is 4 plus 2. That's 6. Let me make sure. X plus 2, yeah. Okay, that's it. We're done with that. Alright, folks, here is a problem number 10. It says a 10-gallon aquarium is 3 inches higher than it is wide. its length is 21 inches, and its volume is 2,730 square cubic inches. What are the height and weight of the aquarium? Basically, this is similar to the problem we solved earlier. Remember the problem of a box? The same thing. This aquarium has, look at it, it has rectangular top and rectangular bottom, okay? But the problem is basically given, the solution is given to you in that picture. Look at that picture. It says the height is x plus, the weight is x plus 3, and what is this, the length? The length is, they give you the length 21. Okay. Basically, it's the length of the rectangular base is 21 inches, and the width of the rectangular base is x. And then it said the height is x plus 3. But you see, let's read the problem again. They said that the aquarium is 3 inches higher than it is wide. Higher than it is wide. See, they're comparing the height of the aquarium to the width of the aquarium. So that gives you a clue. See, when you solve this problem, as you solve many of them, you begin to see pattern, okay? They're comparing that first sentence there, this sentence here. This sentence here is comparing the height to the width. And they're telling you the height, the width is that, right? If the width is that and if the height is 3 inches higher, then see, that's the height there. So you add 3 to it. So basically they give it away there. But if they didn't give us that picture, all you gotta say is you start with, you have to start with width. Because basically they're comparing the height to the width, and they give you a number there. They don't give you anything for the width, okay? You say let x be width, okay? So that's how you normally solve it. If you don't have that picture there. So you gotta pick up on that. That's very, very important. See what is given and what is not given. So if that's the width, and then he said then according to the comparison they did, then the height. Let me see the height. How do I write the height again? The height, I think is it like that? The height is I'm going back. No, it's different. That's not how you write height. I think the way you write width and length is different from the way you write height, right? The way you write height is that. Go like that. You go like that. You go left. You go right. Okay. The way you compare is like you write it is that. So then the height is what? The height, according to what there's 3 inches higher than the width, okay? So you say x plus 3. They give it to you already. They give you all that already, okay? And then that's the length of the rectangular base. Okay, so alright. So now what they want you to, what are the height and the width? Okay, they want you to determine that and determine that. Notice what is given. They gave you the volume. The volume of that, it look like a box. We did that before. Something like that. The volume is like that. The volume is length, width times height. Length times width times height is the volume, okay? Now see what is given. They gave us the volume. We know the height. We know the width. Okay, so basically you plug in what is known. That's all. 2730 is the volume. Is equals to what is the, let me see, the length. The length is giving us 21. You see that right there? Okay. The width is giving us x. and the height is given at x plus 3. So that's all. If you read this carefully, you'll be able to determine what to plug in where. Usually I say this formula will be given to you. If you don't know it, don't worry about that. They will give it to you even if you're in the exam, because they don't expect you to know the volume and area of all kinds of geometric objects, okay? So I'm pretty sure they will give you that in the exam. Alright, because I have done many exams in the past. They will give you stuff like that. So, but anyway, so this is what we'll try to simplify, man. 2730 equals to, what is that? So let's do this first. We say 21 x times x is x squared. X times 3 is plus 3x, okay? And then we'll do this now, okay? 273. You just do it slowly, that way you don't make mistake. Do one thing at a time. Don't start doing a lot of stuff at the same time. 21 times x squared, you get 21x squared, okay? 21 times 3x, and that's a 63x. You see that, right? Okay. All right. So once you get that, let me see. What is that? Hang on a minute. Did I make a mistake? Okay. Okay, everything is fine. So what do you do now? Once you get all these, you want to get the stuff into what they call the standard form. So you say 0 is equals to 21x squared plus 63x minus 2730. Just give me a minute. What did I do wrong, man? You know what I noticed? We could have gotten rid of that 21, but we can get rid of it now. Let's rearrange this stuff. I'll show you what I'm talking about. It's okay. We did too much work, but we could have divided everything by 21 over here. But it's okay though. We just did unnecessary work. So we'll say 21x squared plus 63x minus 2730 is equals to 0. So we can still divide everything by 21. We should have done that earlier. Just keep your eye on that. That way you don't do too much work. Like I said, right here you could have divided everything by 21, but we wasted a lot of time multiplying big numbers. But let's do it now. If you divide 21 with 21, you get 1. Divide 63 with 21, you get 3. See, you get x here plus 3x negative. If you divide 2730 divided by 21, what do you get? You get 130. See that? So we could have gotten rid of that 21 over there. We could have gotten it earlier, because now we did a lot of multiplying here. Now we're doing a lot of dividing here, which is unnecessary, but it's okay. We'll learn our lesson. But anyway, let's look at it now. Equals to 0. Now we'll have to try to solve this. Like I always say, there are 3 methods. You can factor it using this, or you don't like doing this, then you can use you can complete the square, or you can use the quadratic formula. But I like doing this, okay? I like doing this because it's much easier. So to me it's much easier, but it doesn't matter. This is my opinion. Find out which one is easier for you. Now you look for multiples of 130. Okay, so the idea now is to get the multiples of 130. Find 2 of them. When you multiply them, it give you negative 130. If you add them, they give you 3. That's the only thing we're looking for now. And I can tell you now, whenever you see 0 right there, think about 10. All right, think about 10. See, if you think about 10, you will never go wrong. Think about 10. What multiplies? What can multiply 10 to give you 130? 13. And then look. If you have 10 and 13, okay? Yeah, 10 and 13, right? Hang on a minute. You have 10 and 13. Okay, which one do you, because there's x here, there's x here. Which one do you need to make 0 in your opinion? See, look at that. If you multiply those two, you get negative 130. If you add them, you get plus 3. Right there. So let's do x times negative 10. You get negative 10x. X times 13 over here, okay? X times negative 13, x times 13, you get 13x. If you add both of them, what do you get? You get 3x. And that's what is sitting up there. That's what we want. So, again, the idea is you find the multiples of this such that when you multiply them, you get this. And then when you add them, you get this. That's all. If you can find the perfect multiple of that, I can do that, then you're done. So you say like that. See? Let me clear this. I'm just showing you that we did it right with this, so I don't want to run out of space. Basically, when you do that, you say x minus 10 times x plus 13 is equals to 0. Or you say x minus 10 equals to 0, or x plus 13 equals to 0. X equals to 10, or x equals to negative 13. Now, notice that we're dealing with length and width, so that will never, you can't have negative width or negative length. So this is our solution here. Okay, since we're running out of space, I'm just gonna move I'm gonna use the space over on the right hand side. Okay, let's use that. Let's use a little space here. Basically, we're done. We're doing interpretation now. See what it says? It says the height is that. Right there, height is that, width is that. And they want to know what is the height and the width. Okay, so since we got the width as 10, then the height is x plus, you see that, in fact I can even do it here. So the width, we got the, we got the width as 10 inches, okay? Then the height should be x plus, what is that, 3? Let me see, yeah, x plus 3 is the height right here. Okay, so that means what? That means 10 plus 3, that's 13 inches, okay? You see that, right? We're done with that, man. I hope you see that. We're done with that. So we'll move on to the next one. Basically, we're done with that. Here is the next one. This is a toolbox. I have 2 of those. It's a toolbox is 2 feet high. Again, it's similar to what we just did. It's a box. We're dealing with a box. We just finished dealing with a box earlier, right? The height is 2. Its width is 3 feet less than its length. That's the length right there. They give you the thing already. But you always, like I said, you always want to pick up this comparison. Width is 3 feet less than its length. So you have to start with length. You say let x be length, okay? See? That's what they did there. If x is length, you say width is 3 feet less. That means x negative 3 is width. That's all they're telling you there. So make sure you know how to read that. Okay? So if that's the case, you got all this, then it gives you volume. And they give you the height. Find the length and the width. Remember, we just said that the volume of such a box is LWH. You remember that, right? LWH is the such a you multiply length, you multiply width, you multiply height. That's the volume. Okay. So they, like I said, they gave you the problem away, but even if they didn't give it to you, you should know how to do it. Okay, so we'll substitute the given. Look at that. They gave us that. They gave us they gave us the here. That's right there. So we'll substitute all that. We'll get, what do we get? You get 80 for the volume equals to length is x times width is x minus 3, and then what is the height? The height is 2. Now we're now our job is to simplify this. Notice we're in similar situation. Remember when I told you to earlier, don't do too much multiplication. You get rid of the number. I'm talking about here. We did too much multiplication. We could have gotten rid of that 21 there, but we didn't, because we did a lot of multiplications using it. Let's get rid of that. We can get rid of it by dividing. Okay, see, the right hand side is equals to the left hand side. We divide by 2, we get 40 is equals to x times x negative 3. So we got rid of that. You see that, right? And now we'll simplify it till 40 is equals to x times x is x squared. X times 3 is negative 3x. You see that, right? So we want to put it in standard form. 0 is equals to x squared negative 3x negative 40. You see that, right? So we can flip things around. Nothing changes, man. 3x 40 is equals to 0. Okay? So we need to solve this. You choose whatever method you want. Choose the method I like, or you can do completing the square. You can use a quadratic formula. It's entirely up to you. You're free to choose whatever method you. I'm gonna use this. I prefer it. This is actually called factoring. Okay, in case you forgot it, the previous video, there are 3 methods: factoring, completing square. Go watch the other video, completing square. Okay, that's 1, 2, and then 3. What is that? You use a quadratic formula. Okay, quadratic formula. Okay, so those are the 3 methods of doing it. I prefer this one here, factoring. What I'm doing, they call it factoring. What you do in factoring, you eyeball that. You find the factors of that number. Find the factors of. By the way, do you know we're dealing with polynomial, right? But this is called trinomial. There are different kinds of polynomials: monomial, binomial, trinomial. It has to do with the how many tires. Remember, I compared it to the bike. That's the picture you see at the beginning. Okay, monomial got 1 tire, which is 1 time. In our case, in the polynomial case, 1, because when you talk about a bike, you talk about tires, but in polynomial you talk about times. Okay, monomial got 1 time, binomial got 2 times, trinomial got 3. This is a trinomial, got 1, 2, 3 times. Okay, so the method I'm using is you concentrate on the 3rd term. You say what are the multiples of that 3rd term. Once you get the multiples, you say which multiple will be such that when you multiply those 2 numbers, it will give you negative 40. And then when you add the same 2 numbers, it will give you negative 3. That's all. So what are the multiples of 40? Now you gotta find multiple. I can think of 2 times 20. Okay, those are the multiples, right? But they won't work. You see that they won't work. I can think about I can even think about 4 times 10. See, I say whenever you see You see something like that. Yeah, but this time it won't work, because if you make this negative, okay, let's say you make 10 negative, okay? Let's say you make 10. If you make 10 negative, you multiply that, you get negative 40. But let's say now you add it. When you add negative 10 and 4, what do you get? You get negative 6. That's not what we're looking for. This time it won't work. So another multiple you can think of in this case is, let's see, remember, 5 times 8 will give you 40. But we want negative 3, so you gotta put the negative sign here. So if you multiply 5 times negative 8, you get negative 40. If you add negative 8 plus negative 5, what do you get? You get negative 3. So let me show you. So x is here, x is here. These 2x takes care, if you multiply them, you multiply these 2x, you get x squared. That it took care of that one. Okay. And then you have, you can put 5 here, because these are 1 here, it really doesn't matter. Negative 8 here. So if you multiply this and that, what do you get? You get negative 40. See what I did here? You get that. So you multiply that, you get negative 40, which is that. And that takes care of that. Now, if you add these two things, if you add them, what do you get? You get negative 3. Actually, yeah, you get negative 3. That's 3 there. But the way you can get the whole thing is, you say 5. That's why it's cross multiply. 5 times x, you get 5x. Negative 8 times times x, what do you get? You get negative x. I'm sorry, negative 8x. Add those, what do you get? You get negative 3x. See? That's that there. So basically, once you do this, we're done. I'm just showing you that it works. So get rid of that. Get rid of all that. That way you don't get confused. Get rid of all that. Okay, so now that we're done, you said you do it like that. That way you know what you're doing. And then you say x plus 5 times x negative 8 is equals to 0. You see that, right? That's what we're looking for. And then you say x plus 5 is equals to 0, or x negative 8 is equals to 0. Okay. And then you say x equals to negative 5. Or x equals to 8. Supposing you are in an exam situation, right, and you're in a hurry, you don't want to run out of time. Once you get here, let me show you something. Once you get here, I can tell which one will work. I can tell this one will not work, because you see, I can tell you end up with that, because we always say that won't work, because you cannot have negative length, you see. So from here you can tell which one works. If you are pressure by time, you have to hurry up. You just take that, say x equals to 80. You go with it, it will work. Because if you do all this, but if the professor wants you to, teacher wants you to work out the problem, you gotta do all that. You see what I'm saying? So be careful, depending on the kind of exam you're doing. So we know this is the solution here. Sorry. This is the solution we're looking for here. This one here is the solution. Okay, so x is equals to 8. With now interpretation, x is length, because the problem said, well, find the length and the width. We just found the length. Okay, the length is let me see, is 8. What is that? Is that feet? Or let me see. Length is feet. Yeah. Length is 8 feet, and then the width. Okay, the width is what they say, x minus 3. Yeah. Let me see. That's the stipulation. We started with x minus 3 is width. Okay, so that's the same thing as what? The same thing as 8 minus 3 is the same thing as 5. 5 feet. Okay, we're done with that, so we'll move on. You see what we're doing, right? Okay, here is our next problem. This is, see, look at that. It's a computer monitor, man. A square computer monitor. Anyway, you say the dimension of a rectangular, it's not square, it's rectangular. The dimensions of a rectangular monitor screen are such that its length is 3 inches more than its width. Again, I always tell you, pick up on that. Let me finish reading. Then it says, if the length were doubled and if the width were decreased by 1 inch, the area will be increased by 150 inch. What are the length and width of the screen? Okay. So you see what they're doing? They're playing with the numbers, man. Don't let that confuse you. Just follow whatever stipulations they're giving you there. That's all. You know, see, they give it away here. Sorry. They're kind of giving it away. See, right there, right there. But let's derive it ourselves. He says the dimension of a rectangular, so it's rectangular, it's not square, screen are such that its length is 3 inches more than its width. More than its width. So you pick up on that. They're comparing length with the width. And they said the length is 3 inches more than the width. So then the first thing you say is, let x be width, okay? That's all. Because since that sentence there gives it away. Then if that's the width, then it says what is that? The length is 3 inches more. That would be plus 3 would be length, okay? You see that, right? All right. So then we keep reading. If the length were doubled and if the width were decreased by 1 inch. Okay, see what they're saying there. If the length were doubled, the length is that. Double it, you get 3. I think that's what they're saying. 3, I'm sorry. Double is multiply. Multiply that by 2. That's the length. Multiply by 2. And if the width were decreased by 1. Oh my God. This is confusing, man. And the width decreased by 1 means negative 1. I mean, what the hell is going on? This is a little confusing, man. But it's okay. I think that's what they're saying. Because you gotta read it in sequential order. Right? You gotta read it. First they gave us that. That's the stipulation 1. Then they stipulate this. This is length. And this is width again. Okay? So this stipulation here. The second stipulation, let me see. If the length were doubled and if the width were decreased by 1, the area would be increased by 150. See, they're saying area. Area will be increased by 150. Area plus 150. Oh. What are the length? I see. Make sure you understand that. The area will be increased by that. So this problem is, see, you gotta be very careful. You gotta be very, very careful with this problem. If you're not careful, you're gonna make a mistake. Okay? So I don't really know why they're compounding all this stuff. This is the way I understand it. Oh my God. Okay. So that's a box, right? The area, what is that? No, it's not a box. It's just a rectangular thing. So we know from rectangle the area is length times width. We know that because we've done that before, right? Here is what the problem is saying. We started from here, right here, then went here. And here is what it's saying. This stuff is confusing though. How do you put all these together? Is it decrease or increase? Area will be increased by, okay, increased by that. Okay. How do you formulate this, man? I know that this is the length and this is the width. So I know that area is equals to, what is that, length times width? So you say 2x plus 3. Yeah, the stuff is really confusing. Times x minus 1. You see that, right? Okay, so we know that the right hand side is that, but what are they saying that area is increased by that? If this is the area, it's increased. So I really don't know how they want me to formulate this. This is actually very confusing. Okay, that's the area, right? Well, wait a minute. I think I know what they're doing. Sorry. Because you got two stipulations. Stipulation number 1, okay? And stipulation number 2. Okay, I know what they're doing. Because here, remember, you still got area. Area is length times width, which is the same thing as x times x plus 3, right there. But over here they said that is increased. It's increased by that. I don't know if you see what I'm saying. So this is the initial area, and if you increase something, if the length were doubled and the width were decreased by 1, then you get that area. Area will be decreased by that. So you have an area there, and you have well, basically what happened is that's area. We know that, just as we know here. Okay. Okay. So based on stipulation 2, you're gonna have 150. Is it decreased or increased? Area will be increased. Okay. You're gonna have area like that. You see that area plus 150 equals to that. So to get rid of the 150 on the left, you say area is equals to 2x plus 3. That's how I'm reading this. That's another way to read it. Let me know. Minus 150. So I'm saying this area has to be combined with this area. I think that's what they're crazy doing, man. I don't know, man. This one is, I've never seen anyone like this. So yeah, because the stuff is really confusing, man. I don't know what they want me to do. What they're asking, what are the length and the width of the screen? I mean, they gave you two stipulations. I was like, what do they want me to do? How do you combine those two? Should I say this area here is x times x plus 3, right? Let me see. Yeah. Should I equate that to 2x plus 3, x minus 1, negative 150? I mean, I don't understand. I really don't understand what they want, man. So this one got me, man. So this is the original area. When they do something to it, you get that and you get this, yeah? Oh my god. Yeah, I think that's what they want. Let's simplify that and see, man. I think, which doesn't make sense. Why are they making it confusing stuff like that? I really don't know. Let's simplify this and see what happened. You multiply out x times x squared, x times 3x, okay? It's equals to, you do the same thing. Okay, let me see. Let's start with this first. X times x, okay, leave 2 by itself. X times x, this is 2, sorry. We don't want to get confused. Let's start all over again. We'll leave 2 by itself, okay? And then we'll do this bracket first. X times x is x squared. X times 1 is negative x. 3 times x is plus 3x. 3 times negative 1 is negative 3, okay? Subtract 150, okay? We keep going. Don't worry about it. We'll keep going, see what happens. X squared plus 3x is equals to, so what is going on there? Let's do it slowly. X squared minus what? Look at that. Combine those two, you get plus 2x negative 3 minus 150. So you keep going. X squared plus 3x is equals to 2 multiply at 2x squared plus 4x negative 6 minus 150. See that, right? 150. Okay. So look at both sides. We'll have to put it in the form of the standard form. So we can move all that to that side if you want to. Okay, so let's do it. Let's do it and see what this stuff comes up. If it comes up right, I will know. If it comes all messed up at that, then I know I did something wrong. Let's do it, man. So we say 0 equals to 2x squared plus 4x. Combine this. Negative, what is that? Negative 156. See, plus negative x squared negative 3x. So 0 is equals to, what is that? This and that and that and that. Okay. What is that? Okay, that's x squared. Okay. This and that is x plus x. You see that, right? And then negative 156. I don't know if you see, did I do it right? You see that, right? I think I did it right, man. So that's what they want. So let's rewrite it. We said x squared plus x negative 156 equals to 0. That's the standard form. So now, like I always say, use whatever method you want to use. I'm going to factor it the way I like factoring it. You can use the quadratic formula. You can use completing the square. I just want to factor it, okay? What are the factors of 156? Such that when you multiply them, they will give you negative 156. When you add them, they will give you x. That's all we're looking for now. Okay, here are the list of the factors of 156. You see, if you look at them, you list them, you look at them, none of them will work except this one. Make any of them, well, you gotta make, because we're looking for positive x, you make 12 negative. So what is that telling me is here? This is what that telling me. I make 12 negative, okay? And I make 13 here, x here, x here. If you multiply this, you get x squared. Okay, you multiply this, you get negative 156. You add this, you get 1, which is the thing you see here. So that will work. I'm running out of space. You see that, right? So I hope you see that. So we did that right. Let me clear this off. We'll clear this off. That way we'll have space to work with. Okay, so we'll say these will be the solutions, okay? Based on what we've been doing, we're looking for length and width. This one won't work, but let me show you. This one is not gonna work. Let's go here. Let's go here. We'll say x minus 12 is equal. Oh, sorry. I'm going too fast. Slow down before you crash. X plus 13 is equals to 0. You say x negative 12 is equals to 0, or x plus 13 equals to 0. That means x equals to 12 or x equals to negative 13. Okay, so we know that negative doesn't work with length and width. So what we got is there. So what is our first stipulation? Yeah, see, this is where it gets confusing, man. Which stipulation do you use? See, that's where they got us all confused. Define length and width. We started with that. Length length is s, which is 12. Okay, from the first stipulation, if length is 12, width is 12 plus 3. So length 12, width 12 plus 3. Okay, that's the first stipulation plus 3. That's 15. Yeah, right there. No, as I switched it. Width is 3. Sorry, I switched it in. I inverted it. So it's actually length. No, width. Sorry. What the hell? Width is that. Length is that. Okay. Of course, it makes sense. Width cannot be longer than length. Okay. So that's from the first stipulation. So see, the thing is, I don't know. This problem is confusing, right? So what do they want? They gave us two stipulations. I know the second stipulation is where we use that too. So how do you determine the width? What is the width and what is the damn? Well, I don't know, man. I'll leave it like that, man, because this is a little confusing. Because we got two conditions. It means like this is length again, this is length again, and this is. But you see, how did they get that length? They decrease it, and then they decrease the width by 1 inch, and then they double the length, and then they say the area will be increased by that, So this thing is a little bit confusing. I don't really know why they're doing it like that, but here is what I got. We'll leave it like that, man. I'm done with that problem. It's a little bit confusing. Let's move on, man, because we got a lot of stuff we need to cover. All right. Okay, now we're doing keyboard. We did monitor, now we're doing keyboard. Anyway, it said a computer keyboard is 11 inches longer than it is wide. If the length were doubled and if 2 inches were added to the width, the area will be increased. See, the same problem. They're doing that thing they did earlier, man. It's a little bit confusing. It's okay, man. What are the length and the width? See, remember what we did before? We're going to have to do it again. They give it to you here. There are two stipulations, okay? All right. This is stipulation number 1, okay? And then we have stipulation. I don't know what they're trying to achieve doing it. Number 1, this is number 2, okay? Stipulation number 1, what they say? They say a computer keyboard is 11 inches longer than its width. So that means you let the width be x, and then the length will be, what is that? X plus 11. That's all that is saying. Now you say if the length were doubled and if 2 inches were added to the width. You see what they said? If the length was doubled, the area would be, oh my God. If the length were doubled, right? If the length were doubled, so the length double the length, 2x plus 11. Okay. And the width, this is the new length, okay? I don't know why they're doing this, man. The new length, the new width. If the length were doubled, the width, what's that? Width added to the width. So say width is plus 2 plus, x plus 2. And then it said the area will be increased by, so here you have an area. Area will be area plus 198. Notice that there's area here too. Here area here area is don't forget this thing is like a rectangular object, so area is hang on, area is length times width. I think, yeah, length times width is the area. Yeah, see, when they do like this, they tend to complicate stuff, man. And they tend to make it confusing. What is that? All right. Yeah, they make it confusing unnecessarily. I don't know what that thing is leading to. Okay. Area is length. Area of, because that thing is rectangular, right? Area is length and width, right? Because we did that many times in the past, okay? So I don't really know what they're trying to achieve. So, but anyway, I know it's the same thing we did before. You start with stipulation 1, you go to stipulation 2, and then you combine them. So, what is the area of a rectangular object? Length times width. Okay? So, we know that. So, what do we know? We know that area is equal to length times width. Okay? So, the first time they gave us area is equal. What is the area given? Okay, no, it's okay. We're not gonna use that. The first time they gave us area is equals to what? X times x plus 11. The second time they gave us area is equals to. Well, you know what? I don't want to run out of space again, so let's use that space there. The second time they say area is equal, well, they say area plus 198 is equals to, what is that? It's equals to x plus 2. Is that increased? Let me see what they say again. Yeah, they added it, so I did it right. Times 2 x plus 11, okay. You see that, right? That's what they want us to do. So we'll have to equate those two, man. That's all. That's what we did before, remember? Actually, let me see. Here, area is rewrite area. X plus that. I've simplified a little bit on the other side. Let me see. Actually, no, let's leave it because we may need something there. 2 times x plus 11. You see that, right? And then we'll move that over 198 minus 198. Okay. So the two areas, we equate them. We have x times x plus 11 is equals to x plus 2 times 2 x minus plus 11. Oh Lord. I gotta slow down, man. That would be a mistake. Negative 198. You see, that's what we're working with, man. You see that, right? So nothing will save us here. We just have to multiply everything out. We're gonna multiply everything out. So let's start multiplying. X times x, you get x squared. X times 11, you get 11x. Okay, on the left side. So multiply here out. We leave 2. Leave this alone and multiply those two things. I hope you can see that. You know, I can move. I know some people will get confused, man. So let me rewrite that as 2x. What they call this is commutative. The things can be moved around. All right. You see that, right? We can write it like this: negative 198. I want you to see that. That way, you know I'm not playing any game. Okay. That's 11. Oh Lord, 11x is equals to. I don't like that. Let's clean it up. Okay. So we leave this alone and start with the other bracket. We say 2 x times x, x squared. X times 11, 11x. 2 times x, 2x. 2 times 11, 22, okay? Alright, minus 198, okay? So we'll try to simplify a little bit before we multiply out. Is equals to 2 times x squared plus, what is that? Well, that's 13x plus 22, 198. Okay, now we'll multiply out. But I gotta carry everything with me, carry it over. 2 times that thing in the bracket, you get 2x squared plus, what is that, 26? 26x plus 44. All minus 198. Okay, so we're gonna put it in standard form. We'll move things over to the other side. We'll get 2x squared plus 26x plus 40. Let's do that. What is that? What are those? We don't want to be, carrying stuff like that. Well, if you do those, what do you get? Do that. That's negative 154, right? Okay. And then you're moving the other one, negative x squared, negative 11x. Okay, this go with that, and this go with that. What do you get? 0x equals to, what is that? X squared. What is that? You subtract that from there. Subtract 11 from 26. What do you get? You get 1 and 5x. Okay. Negative 154. Okay. See that, right? That's what we do, man. So you can see that. See, we did it right? Okay, so we can flip it around. We'll say x squared plus 15x negative 154 is equals to 0. You see that, right? We change nothing. Now, use whatever method you want to factor that. You have to factor that. Use whatever method you're comfortable with. That's all. If you're comfortable with completing the square, complete the square. If you're comfortable with using the quadratic formula, do that. If you're comfortable with the way factoring it the way I factor it, then you do that too. You see that, right? So I'm gonna factor it like this. You're looking for factors of these, okay? So let's find them. All right, here are the factors of 155 listed there. If you multiply any of those things together, you can put negative wherever you want. You get negative 154, okay? All right. But then which one of them is when you add them, you get positive 15? Look at them carefully. That will not work. I know that. That will not work. Because you don't forget that here is straightforward. We got x here and x here, okay? Alright, so we'll know that will not work. Let me see if you add there something. Yeah, it looks like that one will work. I think this one will not work. This one will not work. But that will work. Okay, so think about it. Let's put 7 somewhere here. Put 22. How do you distribute the negative? Put the negative sign here. So negative 7 times 22, you get negative 154. But when you add them, what happens? You get 15. You get positive 15. You see that, right? So let's not waste time. Let's knock it out. I mean, you know how I show you. I can show you that better. Well, I've showed you many times. So with that, we'll say x negative 7 times x positive 22. I can tell you that positive 22 will not work, but let's formally do it. If you're in a hurry, pressed by time, you know the first one, you know this one will work. You should know it. Why? Because x negative 7 is equals to 0, or x plus 22 is equals to 0. Notice that x is equals to 7, or x equals to negative 22. You can't have negative length and width, right? So that one will work. That's why I say if you look over here, you can pretty much tell you move on. Let's say you have multiple choice question. questions. You don't want to be wasting your time. You just take that one and go. But you gotta work it in your head. No, it's x equals to 7, okay? Alright, so we got that. X equals to 7. Let's go back. So what are we doing? Which now that we got that, which one is length? Well, I guess we can use that. So we say length. Width is what is that? Width is 10, okay? No, width is 7. What we got? We got width 7. What is that? Is that inch? Yeah, 7 inches, okay? Width is 7 inches, and then length is 11 plus x plus 11. Length is x plus 11. That's the same thing as 7 plus 11. So that's the same thing as, what is that, 16, right? No, not quite. Hang on. I'm blanking out. Yeah, sorry. That's 18. So length is 18. You see that, right? I don't know what else. I don't really know what else they want me to do. I think I'm done with that problem. Okay. Here is problem number 14. It says a square mirror has size measuring 2 feet less than the size of a square painting. Oh Lord. If the difference between their areas is 32 feet squared, find the length of the size of the mirror and the painting. Oh my God. Now they're comparing the painting, a painting to a mirror. Alright, so let's I don't know what that is necessary. Why are they comparing oranges to peaches, man? It's okay. We'll follow their whatever they're saying and try to solve it. They said a square mirror has size measuring 2 feet less than the size of a square painting. So if the square mirror is 2 feet, then the size of the square painting. So you start with the square painting. If the size x, right, and then the mirror is 2 feet less, okay. Oh, they're both square, but they look rectangular to me. But they said they're square. If the distance between their areas is this, find the length of the size of the mirror and the these are very, very interesting problems, man. So what they're saying is based on what they're saying, right? These are very, very interesting, to be honest with you. I didn't know you could compare stuff like that and come up with but I'm trying to wrap my head about the value of this kind of problem, because if you compare it to things like that, I mean, don't you have to measure it to know which one is which? If you measure it, why are you solving any problem? If you measure the mirror and you measure the painting to determine compare them, you already got the measurement, right? So to measure it before you can compare them, there's no need. It's okay, man. I'm just thinking about why is this thing. Why are they doing it the way they're doing it? But it's okay. We can solve it though. Fine. We can solve it. A square mirror has size measuring 2 feet less than the square of the painting. You see that, right? So they're comparing the side of the mirror to the side of the painting. So you start with the painting, okay? Because that's what they see what they're doing here. So you say they already said let x be the length of the size of the painting. Well, length, okay. Let's use the appropriate word. Be size of painting, okay? Because they will be the same because they're square. Okay, if that's the case, you say a square mirror has size measuring 2 feet less than the size of the painting, then the mirror will be x, let's subtract 2 will be side of mirror, okay? Actually, they give you that over on top. See the pictures? They gave you that. Side of mirror, okay? Okay, if the difference between their areas is 32, find the length of the size of the mirror and the painting. Well, the difference between their area is that. Okay. Now, we'll know what area. We've done this before. Area of a square is a size square, because you remember area of a rectangular. If it's rectangular like that, you have length and width. It's length times width, but this time length and width are the same. So that's why they said it's squared. Okay, it's squared. You see, because they're the same. You understand what is going on there, right? So that's what is going on here. So it's squared like that. That's the side, okay? So we say the side is x. So basically, there's no need to use that. We'll say it's squared like that. X squared. That's the area. That's the area of the painting, the area of the picture. But there's something going on. If the difference between their areas is that 32, find it. Okay, I know what they're doing. So that's the area for any square right there. Okay, let's say for the painting, we'll start with painting. The area, painting area is equals to, what is that? X squared. Okay. Well, let me not confuse you. The size, let's put the size. The sides are squared. Okay, that's general, okay? General area of a square, okay? Alright, so that's the painting. And then the mirror, the area is equals to x minus 2 squared. You see that, right? So you just, based on what you know, you just follow the stuff slowly. And then they said, if the difference between their area is 32 inches, okay. You see what they say there, the difference, see, all that stuff we've been doing with this stuff like this in the past. The difference means x squared for painting minus x minus 2 for the mirror. Well, you're gonna say, well, how do you know which one to subtract from which one? Notice that the painting is bigger and the mirror is smaller. You see that from the picture they gave us. You don't want to subtract the smaller one. You don't want to subtract the bigger one from the smaller one. Then you're gonna deal with negative. So you don't want to deal with negative area or negative length, negative size. So this is the correct one. As it says, their difference is equals to what? Right there, the last sentence. Equals to 32. You see that, right? That's all. We'll solve this. We're gonna solve this, man. Alright, so notice that this is the same thing as 2 minus x minus 2x minus 2, like that. Is equals to 32. So we'll have to deal with this first. X, we'll carry everything else along. X times x is x squared. Oh, don't forget this is minus. X times x is x squared. X times 2 is negative 2x. 2 times x is negative 2x. You see that? That's negative 2 times x, negative 2x. Negative 2 times negative 2 is positive 4. So don't forget that sign there, okay? It's equals to 32. So now we're going to remove that sign. That's where a lot of people will make a mistake. It becomes negative there, becomes positive here, becomes positive here, becomes negative here. See that? Equals to 32. Okay? Alright. So notice this, man. I don't know if we did anything wrong. This stuff shouldn't cross out. We can't have our stuff crossing out like that. Just give me a minute, man. I think there's a mistake somewhere. We can't have x squared there crossing out. If it crosses out, then what the hell? Should it cross out? I guess it should cross out. I don't know, man. That looks weird, man. Okay, so he crossed that out. Because we're trying to put it in standard form, then it's crossing out. We'll cross it out, and they will say plus 4x minus 4 is equals to 32. So basically that's 4x equals to 32 plus 4, which is what, 36. X equals to, that's weird, man, 36 over 4. What is that? So that's what they gave us, man. That I never seen the first term of a trinomial cross out like that. That's why it looks weird to me, man. Anyway, that's 9. So what does that mean? I guess the problem is easy. I mean, that's what they're trying to say. Because, yeah, it has to cross out because it's subtracted. Right? Subtracting one from the other. I think that we're done. So let's go to stipulation. X is the side of the painting. So the painting got 9 inches, okay? Okay, for the size. For each size, okay? And then mirror got what? Let me see, what does it say? Mirror is x minus 2. Mirror is x minus 2, same thing as 9 minus 2 equals to 7. So mirror got 7 inch size, okay? So each side is 7 inch for the mirror. For the painting is that. I think I'm done with that problem, man. I'm done, man. Let's move on. Okay, here is the next problem. Let's read that. It says the size of one square have length 3 more than the size of a second square. If the area of the larger square is subtracted from 4 times the area of the small square, the result is 36. What are the... Okay, see the same problem, man. Just reformulated different way. So you see the same problem we just did above. So, and you see they give you all that stuff in there, in the bigger square and the smaller square, okay? So they say, but you see, you gotta understand the problem. That way you don't make mistake. The size of one square have length 3 more than the size of the second. Okay? So let x be size of second, okay? Second. I guess this is the second, okay? Alright, because they compare they say the size of the first. The length of the first is 3 more than the size of the second. The square have, the first square has length 3 more than. So then x plus 3 is the size, okay? Size of first square, okay? That's all that is saying. This is the first square. This is first here. This is second here. That's what that picture is saying. So that's what is going on there. You see that, right? All right. So let's see if the area of the larger square is subtracted from 4 times the area of the smaller. The result is that. Okay. So the area of the all right. Do you know we did this before? The area of a square generally is S. This is the general, right? General area. Sorry. This is the general area of a square. Okay. And then the second has area. For the second, okay. second area is equals to x squared. For the first, okay, the first square, that's the largest square, area is equals to, okay, x plus 3, because they said the first one I have 3 more than the size of, okay. Alright, see the second stipulation. If the area of the larger square is subtracted from 4 times the area of the smaller. Okay, so the area, the second stipulation, they say 4 times this. Okay, and then we'll subtract the larger square, subtract from 4 times the smaller square, then the result is that. You see that? 4 times the first one is that. They say if the area of the larger square is subtracted from 4 times the area of the small. Okay, so what they're saying is if x is subtracted, actually subtracted from, that means 4x, like that. You see that, right? If the area of the square is subtracted from 4 times the area of, yeah, it's subtracted from, it's like that. We'll subtract this from that. You see that, right? They said then the result is 36 square meter. You subtract, the result is equals to 36. That's all they're saying there, man. Make sure you understand that carefully. Read it the best way you can. Make sure you understand it. Okay, so make sure you understand it. Once you understand it, you move on. You solve it, man. That's all they want there, man. You know, so some of this problem can be tongue twisting, man. You just have to read it carefully, analyze it, understand it, and then you move on. You know, don't overthink it, man. If you overthink it, you make a mistake. The most important thing for you to do is right. So let's simplify the things. We say 4x squared is negative x plus 3. X plus 3 is equals to 36. So let's take care of that first. But we'll carry everybody along with us. Leave nobody behind, man. Okay. Let me put that into bracket like this. It will be 36. Okay, x times x is x squared, okay? Alright? X times 3 is plus 3x. 3 times x is plus 3x. Okay, 3 times 3 is plus 9. You see that, right? Now we'll remove that bracket. We get 4x here minus x squared minus 3x minus 3x minus 9 is equals to 36. You see that, right? Okay. Alright. You see what I did? I didn't do anything illegal. I did everything according to the stipulations, okay? Alright. So how do we keep simplifying? 4x squared minus x squared minus, what is that? 6x minus 9 equals to 36. Okay. So notice that this will take care of itself. Okay, so let's do one at a time. You get 3x squared minus 6x minus 9. Yeah, do one at a time. That way you don't get confused. Equals to 36. Okay, we'll move things around. That way we'll move 36 to the left. That way we put it in standard form. Remember, before you solve anything, it has to be in standard form. Minus 6x minus 9 minus 36 is equals to 0. Okay. Minus 6x. What is that? Minus, it's a 40. What is that? 45. Right? Okay. Alright, that's where we landed, man. Ego has landed down. Equals to 0. So we need the multiples of that. What are the multiples of 45? That's what you have. You have to worry about that right now. What are the multiples of 45 that will work? There are many multiples of 45, but which one will work for us? That's all. So I can list them for you. I can list the multiples of 45. The multiples of 45, oh Lord, is... Okay. Multiples of 45 is 1. At least I know 1 times 45. I know 3 times 15. I know 5 times 9. Now, I bought them. We multiplied any of them, we get that. Okay? But so which one we will add? One of them has to be negative. Which one we will add that will get negative 6, 6? Look at it carefully. It can be, this one won't work. Okay? If we make any of them negative, let me see, make that negative, that one won't work. Because even if you make this negative, yeah, it won't work. What of this one? Okay, it's kind of fishy, man. Oh, look at what we have. Sorry. You gotta look at the other term, man. You gotta look at the other term. I forgot the first time. The first time in the trinomial, you gotta put that into consideration too. I forgot to put that into consideration. Oh, okay. Sorry. Let's backtrack. I'm gonna backtrack now. I messed up with my own rule, man. Let's backtrack a little bit. What we're gonna do? Let's divide everything by 3. So we get x squared minus 2x minus 15. You see that, right? Equals to 0, right? So that's what we actually need to factor. Sorry about that. So we need the factor. It's easier now. We need the factors of 15. Okay, here are the factors of 15. 1 times 15. You see? So by doing it, by dividing by x, we reduce the complexity of the problem. You see that, right? Okay. So I think this one won't work, but that will work. Because if you say 5 minus 3, you get 2. But so let's make this negative here. So basically, if you do it like this, let me show you. You go like that, you put x here, you put 3 here, you put negative 5 here. Okay, so when you add 3 and 5, you get negative 2x. You see? So basically, that's what we've done. Let's you know how I did it. Look. If you don't look at the previous problems I solved. So we've done x plus 3. That one will not work. I'll show you. X minus 5. That one will work. Equals to 0. X plus 3 equals to 0. Or x minus 5 equals to 0. Notice that x is equals to negative 3, or x is equals to 5. This one won't work because we're dealing with size. The length of a size, length cannot be negative. So that's right there. Alright, so we got that. What does that mean? Now, the next stage is interpretation. You have to interpret the result you got based on the stipulations you did. You see what I'm saying? So based on the stipulations we did, we'll say that the side of the small one is x. So the side of the small one is 5. You see that, right? Small one has side for the small one is 5. Then side for the big one is 5 plus 2. This is small one. They call it the second one, the big one. Okay. Then the side is x plus. Is that x plus 2? Yeah, x plus 2. So that's 5 plus 2, that's 7, okay? Inside is 7. You see that, right? That's what is going on there. The small one has side 5, the big one has side, wait a minute, 5, yeah? Has side like that. Okay. Alright, sorry about this. You see, I made a mistake, I corrected it. I said something, I wrote something. It's x plus 3. So sorry about that. This is actually x plus 3. So that's 8. Okay. So you see my mistake. But I did the problem right. When I started solving the problem, I used the correct, you see there, right? I used the correct one. But I wrote it wrong, so I corrected it. So make sure you make correction there. Because that's what the problem said. The side of the larger one is 3 more than the side of the second one. Okay, I don't know why I wrote x plus 2 there. Anyway, so I corrected that. Everything I solved with the right, with the corrected stuff. So we're done with this. I don't know what else we should do. I mean, if you go to the second stipulation, you can put that in there. I think I know what they're doing. If we put that in the second stipulation, let me show you. If we put what we found in the second, x equals to 5, you put it here. X equals to 5, then you get 5 squared. That's 25, okay? And then for the area, you get 5 plus 3 squared. What is that? You get 8 squared. That's what they're doing, man. And then you do all that, so yeah, I don't know what they're trying to prove there. That becomes 64. Okay, so I don't know what they're trying to prove there, but I think maybe it's a way to check it, you see. So but anyway, I don't want to, I made that mistake right here. I just wrote it wrong right there. I wrote 2 here, but I corrected it. But what happened, I made the mistake. I wrote 2 there, but I didn't carry the mistake over. I corrected it here. It's x plus 3, not x plus 2. So there's nothing to change. The problem, I solved it right. You understand, right? So we leave it there, man. There's no need to go back and start redoing that stuff. Alright, here is the next problem. It says the length of a rectangle is 5 inches longer than its width. The diagonal is 5 inches shorter than twice the width. Find the length, width, and diagonal measures of the rectangle. Okay, you see the picture they drew there helps you to see it. So we're dealing with a rectangle, right? They say the rectangle is 5 inches longer than its width. So a rectangle has length longer than, normally the length is longer than the width. Okay, so if this is the length, then that's the width. But let's use the stipulation given us. See, they drew this thing here, said that is 90 degrees, okay? That shows that it's 90 degrees right there. That angle is 90 degrees, okay? This angle here is 90 degrees. That's what that is saying there. Alright, so we might have to use a Pythagorean theorem. But let's see what they're saying. The length of a rectangle is 5 inches longer than its width. Longer than its width. We'll say that's the Q there. Let x be the width, okay? Okay, then it said the length. Well, let me do it properly for you. Then length, right? Length will be, since length is longer, length will be is x plus 5. You see that, right? Okay. And then he said the diagonal. What is diagonal? Diagonal is you draw a line. It's this the line here. Yeah, you should know that, but they put it there for you in case you don't know. That's what they call diagonal. They put the word diagonal there. The diagonal is 5 inches shorter than twice the width. So they're bringing the Pythagoras Theorem here. The diagonal is 5 inches shorter than twice the width. This is the width here. So notice that this is one leg and this is another leg of a right angle triangle, and the diagonal is the hypotenuse. Diagonal right here is the hypotenuse. Okay, look at the hypotenuse. Okay, you see that, right? Okay, so what they say is diagonal is 5 inches shorter than twice the width. So diagonal, which is the hypotenuse, okay? Hypotenuse is 5 inches shorter than twice the width. So twice the width is this. Well, we already defined width as x. We don't want to make it complicated. The width is x. Twice the width is that. Diagonal is 5 inches shorter. So subtract 5. 5 inches shorter than twice the width is right there. So these are the stuff they gave us. So we need to find the length, find the width, find the diagonal. Don't forget this is the diagonal here, okay? Diagonal is the hypotenuse. I don't want to confuse it. Diagonal. It's the same thing as the hypotenuse, okay? Diagonal. Okay. So these are what is giving us. They don't give us the area, so we can't work with the area. So basically the problem wants us to work with Pythagorean Theorem. Remember Pythagorean Theorem, a squared plus b squared equals to c squared. That's if this is a, this is b, and this is c. Okay, so let's prove what we have. Okay, basically this is the length, the width is that, is a, the length is that, b, the hypotenuse is c, is that. So we'll say x squared plus x plus 5 squared is equals to, see that, right? 2x minus 5 squared. That's all they're saying, man. That's all. So once you get the value of x, then you come back and use that value to see what is what in the stipulation here. Okay, so let's solve. Let's solve this. I like to expand it. You gotta expand it and put it in the standard form. The standard form is ax squared plus b times x plus c equals to 0. We have to put it in that standard form. So let's do it. X squared plus x plus 5 times x plus 5, okay, is equals to, I'm writing it that way, writing it out. That way you don't make mistake. I can do it in my head, but it's not necessary. I end up confusing you see. So let's write it out. 2x, alright, like that. Now you start removing the brackets. X times x is x squared. X squared. X times 5 is 5x plus 5x. 5 times x, another 5x. 5 times 5 is 25. Okay, so equals to, we'll do the same thing on the right hand side. 2x times 2x, you get 4x squared. You see that, right? 2x times, you get negative 10x. Negative 5 times 2x, you get another negative 10x. You see that, right? And then 5 times 5, you get plus 25. Okay, so now you gotta simplify all this, man. Just remain calm and then see what can be combined. That's all. I start from the left. You see, I can combine these two. I can combine these two. You see that, right? On the right, I can combine these two. Okay, so let's do it. 2x squared plus 10x plus 25. You see that, right? It's equals to, check that out, 4x squared minus 20x, okay, plus 25. You see it, right? Okay, so we can move to make it standard form. We get the things on the right hand side and move them over to the left side. So we have 2x plus 10x plus 25. Based on where I'm standing, I can see stuff that cross. I don't have to move it around, but I don't want to confuse you. So let's do it the way we're supposed to do it. That way we don't make mistake, okay? Okay, then you subtract 4x squared. Then you add 20x and you subtract 25, and this equals to 0. Now notice this cancel that. Okay, that and that. What do you get? Well, you see, you don't want to get negative 1. Well, it's okay, we can fix that. You get negative, what is that, negative 2x squared, okay? Okay, and then what else do you get? You get that and that. You get 30x, and then say equals to 0. See that, right? So we can move it over. Say 0 is equals to, or if you want, you can multiply by 1. Let's multiply by negative 1. See the same thing. Multiply by negative, because you don't want, the standard form doesn't have the first term negative. It has a positive. Multiply by negative 1, you get 2x squared minus 30x is equals to 0. You see that, right? Actually, this is so easy to solve. You don't need to use any quadratic equation formula. You don't need to complete the square. You don't need to do that method. Would do like that. I'll show you why. Look at it carefully. We've done stuff like this in the past. When we multiplied, when we divided by polynomial with monomial. Check this out. That's why you gotta pay attention. Keep your eyes on the ball. Look at this. I can write this as look at that. 2 can divide. I can write 2x minus 15. You see that is equals to 0. You see that? I can pull 2x out. Because if you multiply 2x times x, you get 2x squared. 2x times 15, you get negative 30x. So now you divide both sides by 2x, divide that side by 2x. What do you get? You get x negative 15 is equals to 0. X is equals to 15. That's all we're looking for there. You see it, right? So this one turns out, I think when you subtract things like that, it turns out to be there. Actually, it's either x equals to 0. I forgot x equals to 0, right? So you have to be careful, because you know why x equals to 0 is there too. It's because over here, when you do this, right? When you do it like that, no, it's okay, man. That's useless to us, because length cannot be 0. So forget about that, But if your teacher wants you to do it, you can do it. But you end up it's useless. I think it starts from here. It starts from here. Let me show you. Let me make sure I do it right for you. You can say 2x equals to 0, or x minus 15 equals to 0. And then you say x equals to 0 or x equals to 15. So you arrive at the same thing. Length or width cannot be 0. You cross that out. So you end up with the same thing. You see that, right? Okay, so once we end up with that, look at our stipulations. So the width is 15. The length is 15 plus 5, which is 20, right? And then the hypotenuse is 2 times 15 minus 5. So let's do it. So what is that? The width, length, and hypotenuse. They call it diagonal. Length I'm sorry, start with width, right? Let's do width first. Width, length, okay, and then the diagonal, gonna something as hypotenuse, okay, hypotenuse, okay. The width is x, and the length is x plus 5, and the diagonal is 2x minus 5. 2x minus 5. So let's say, based on what we found, right? So the width is 15. So here the diagonal is, 15 plus 5. That's 20. Not diagonal, length, sorry. And then here, the diagonal is 2 times 15 minus 5. Okay, that's 30 minus 5, and that's 25. You see that, right? So that's what we got. I don't know what else we can do. That's what these are in inches, man. All these inches, and the inches, okay? I think I'm done with that problem. We'll leave it alone. Okay. This is the next problem. Let me read that. The length of a rectangle is 4 inches longer than its width. The diagonal is 8 inches longer than the width. Find the length, width, diagonal measures of the rectangle. It looks like the same one we did before, because they're saying, see, they're comparing length and the width, right? And then they're comparing diagonal and the width. And notice that what it says, this is a rectangle. So if I draw it, it would be like this: rectangle, the length is greater than the width, and then this is 90 degrees. You know, all the angles are 90 degrees, but this is the diagonal right here. Okay, so let's say it says let x be width, because that's what they're doing. They're comparing like that. So we'll start with what they're comparing. Okay, and then if x is width, then the length of a rectangle is 4 inches longer. Then length is x plus 4 inches longer. Then the diagonal is 8 inches longer than the width. Then diagonal is 8 inches longer than the width, x plus 8. So this is the diagonal here, and this is the length, and this is the width. And well, let's represent what we got. Let's use what we got. The length is x plus 4. The width is w. I'm sorry, not w. It's x, because we don't want to confuse people. X. Okay. So don't worry about, well, I can write this. Diagonal is x plus 8. So this is a situation we have to use the Pythagoras Theorem. Pythagoras Theorem says that a squared plus b squared is equals to c squared, where this is c, a, and b, okay? So we'll do x squared plus x plus 4 squared, okay, is equals to x plus 8 squared. That's all that is saying, man. And then you gotta simplify. We'll start by note this, because I want to do it the way you will make mistake. Just expand it. You see, that equals to x plus 8 times x plus 8. You see that, then carry everybody along. X times x is x squared. X times 4 is 4x. Then you start with 4. 4 times x is 4x. 4 times 4 is 16. Is equals to, do the same thing on the right hand side. X times x is x squared. X times 8 is 8x. 8 times x again is 8x. 8 times 8 is, I think it's 64, right? Yes, it's 64, okay. So we have to simplify, well, combine stuff first, and then you combine it first, you get, what is that? Actually, you get 2x squared plus 8x plus 16 is equals to x squared plus, what is that? That's 16x plus 64. Okay, so you move things to the left. You get 2x squared plus 8x plus 16 minus x squared minus, let me see, minus 16x minus 64, all equals to 0. Okay, so you combine like times, you get x squared, see this and that, and then you combine this and that next. Okay, so that will give you negative 8x, you see that, right? And then combine this and that. You see what I'm doing, right? You know, that's how you do it, man. And you get, let's see, negative 48 is equals to 0. Okay, you see that, right? So make sure you understand what I've been doing, because that will, you know, sometimes I like to go fast, but that's okay. So that's what we end up with. What is this we're doing? This is number 17. Okay, all right. So you see that, right? Oh my God, it's a lot of. We're almost done though, so let's keep pushing on, and then we'll be done in a minute. So that's what we end with. How do you solve this? Use whatever method you want. A quadratic formula, completing the square, but I'm gonna use this factoring. This is factoring. Now you're dealing with 48. What are the factors of 48? That's what you gotta worry about now. Find the factors of 48, and then find which pair of factors will solve the problem. That's all. You know, the factors of 48, right, is you have factors of 48. You know, it's always with 1. 1 times 48. Okay, that one, no, that won't work. 2 times 24. Based on what we're looking for, that there. I know that won't work either. 3 times 16. Okay, I know that won't work, because don't forget, if you look at the other time, it's x here, so there's nothing there, there's no hiccup there. So another thing is 4 times 12. Will that work? That, yes, I think it should work. There is also 6 times 8. Okay, so let's see, that won't work. This won't work. This won't work. This won't work. Let's look at that. We'll concentrate on that, okay? Okay, so we'll put 4 here, we'll put 12 here. So which one, how do you do this? You do, since that's negative here, you put negative here. 4 times 12 is negative 48. I'm sorry, 4 times negative 12 is negative 48. Then if you add them, you get negative 8. So we'll solve it right there. So the most important thing is find the factors of 48, the factors of the third term, after you put it in standard form, okay? So what we got now is x plus 4 times x negative 12 is equals to 0. X negative 4 is equals, I know this, well, both of them could work. No, this is plus, sorry. Man, I'm glad I caught that on time, man. This is equals to 0, or x negative 12 equals to 0. X equals to negative 4, which won't work. X equals to 12. So length cannot be negative. See, we're dealing with length. So the thing that will work is that one. So what do we have? You see what we describe. So we got width, we got length, and we got diagonal. Okay, diagonal is the hypotenuse. So by now you know that diagonal. Okay, so this is x. Let me see, this is x plus 4, right? What is that? X plus 8. So the width is 12. The length is 12 plus 4, which is 16. The diagonal is 12 plus 8, which is what? Which is 20. And then we're done with this problem, man. You see that, right? That's how you solve it. I don't know what else. I don't know what else to do. We're done solving that thing. We're done. So let's move on. That way we can knock this out and find something else to do. Look at that. Look at that. He says, oh Lord, he said, tram walks due north of home. Okay, that's where he goes to work. Tram goes to work north of home. Her husband Alan works due east. Alan goes to work in the east. Okay, they leave for work at the same time. By the time tram is 5 miles from home, the distance between them is 1 mile more than Alan's distance from home. How far from home is Alan? You see, they're playing with words here, man. So this is their home right there. See, they drew this here and they put right angle here. This is 90 degrees. This angle is 90 degrees. That tells you we'll have to use a Pythagorean theorem. Okay, this is home here. Okay, tram heads north. The wife heads north. And the husband heads east, like that from home. Okay. And they're saying they live at the same time. By the time tram is 5 miles from home, the distance between them is, you gotta look at this distance, okay? That's the distance between them. Distance between them is 1 mile more than Alan's distance from home. So distance between them is compared to Alan's distance from home. You see that, right? So you gotta keep your eyes on the ball, man. You keep your eyes on the ball, you'll see. Really carefully understand what they're saying, then you shouldn't have problem, okay? So let's okay. By the time tram is from home, distance between them is 1 more than Alan's distance from home. Okay, so you see, that's your key there. Let X be Alan. They even put it there. Alan's distance, okay? Distance from home. Distance from home, okay? Alright. They put it there for you, X. And then they say because he says when by the time it's 5 miles from home, right there, they put that 5 there. Alan's distance from home is X. So that means when Alan's 5 X distance from home, what is tram? Tram distance is exactly, well, they put it as 5. So there's really nothing more to solve. You know, you have to I think he don't need any more then what they say more? By the time tram is 5 miles from home, the distance between them is, okay, this distance here is Alan has, it says 1 mile more than Alan's distance. 1 mile more. We know that Alan's distance is X. So this here has to be 1 more like that. You see that, right? So basically they're playing with words, man. This is Pythagorean situation. Pythagoras, you remember, is equals to c squared, okay? And this is a, b, and this is c. So use Pythagoras, you have 5 squared plus x squared, this is a, equals to x plus 1 squared. Alright, so this is 25 plus x squared equals to, let's say, x plus 1. I like to expand it, x plus 1. Then you multiply that. Let's put x first, and then 25 is equals to x times x is x squared. X times 1 plus x. 1 times x plus x. 1 times 1 plus 1. You see that, right? Okay, now we simplify, okay? We simplify it that way we don't make mistake. X, carry everybody along. X squared plus 25 is equals to x squared plus 2x plus 1. And then you move everything to the left to make it standard form. X minus squared plus 25 minus x squared minus 2x minus 1 is equals to 0. You see that, right? This will cancel that. You see it, right? And then we'll have 25 minus 2x minus 1 is equals to 0. Alright. So that's the same thing as, let's see, 24 minus 2x is equals to 0. So we got 24 is equals to 2x. Okay? So then if you divide everything by 2, you get 12 is equals to x. You see that we got x equals to 2. Alright. You see that, right? X is equals to 2. That's what we're looking for. So I don't know how else you solve that. That's what we're looking for. So we got that. So what is x? X is Alan's mile right there. The mile of Alan from home, okay? And then the distance of them, x plus 1. Okay, we got trace distance. So Alan's distance, okay? From home, okay? From home is 12. Okay, what is that? The diagonal is x plus 1. And that's the, what is that diagonal? Is the distance between them. Okay, distance between Alan, what is the wife's name? Tram. Alan and Tram, okay? Distance between them, x plus, what is that? X plus 1, which is same thing as 12 plus 1. That's 13. Okay, so all this stuff are in miles, okay? This is miles, and that's miles. Okay, so we're done with that problem, man. There's nothing else to do. So let's move on to the next one. The next one says, two cars left. It's the same problem, man. It's the same problem, just different translation into words. Two cars left an intersection at the same time. This is the intersection here. Remember, the other problem is the home of the husband and wife. One travel north, the same thing. One head north. Okay, he heads north there. The other one travel, it doesn't say yet. The other travel 14 miles further, but to the east. The other one head east, but 14 miles further. See, they say x plus 14. That one is x. How far apart we are there at that time if the distance between them was 4 miles more than the distance they traveled? Okay, see, they're playing with words here, man. This is 90 degrees right here. So you know you gotta use Pythagorean. And they give you x and they give you, it's like they give you leg A, they give you leg B. And this is a hypotenuse here. And the hypotenuse, how do they define? That's the distance between them, hypotenuse. See what they said there? How far apart they were there at the time? If the distance between them was 4 miles more than the distance traveled east. More than distance traveled east. So basically, see, distance traveled east is over here. So that what they're saying, 4 miles more than distance traveled is. So they're saying is x plus 14 plus 4. That's what the hypotenuse stands for. That's what that problem is saying there, man. You gotta read carefully. So basically, that simplifies to hypotenuse x plus, what is that, 18. That's what that simplifies to. Okay. So what this problem is telling you, let me change the color. It says x squared. Well, to do it properly, let's do it properly, because the diagram already giving it away, but let's do it. Okay. The other travel further but to the east. So the one going north, the one heading north, he said let the one heading north, let the northbound car, okay, the distance it travel, right, distance, okay, is x. Then the eastbound car, okay, eastbound car, the distance, okay, distance that car travel based on what they're saying. The other travel further but to the east is then x plus 14. And then later it says how far apart were they if the distance between them, this plus from here to here, if the distance between them is 4 miles more than the distance traveled east. So they basically say hypotenuse, okay? I already showed you, I did it over there. It's x plus 18. That's all they're saying there. So you put all that together using Pythagorean Theorem. You have x squared plus x squared. You gotta slow down, man. X squared x plus 14 squared is equals to x plus 18 squared. That's all they're saying, man. Okay, because I said, you see, that's 90 degrees there. So you simplify the way we normally do. That way you don't make mistake. What we normally do, carry everybody along. We'll say x plus 14, x plus 14. That's the same thing, okay? X plus 18 times x plus 18. So we'll try to multiply things out. That's all. That's all that is saying, man. We'll multiply things out and see what is going on. That's all. You see that, right? So I like to write it that way I don't make mistakes right there. X times x is x squared. X times 14 is 14x. 14 times x, another 14x. 14 times 14. This is where it gets a little bit gets. You gotta use long multiplication to get that. If you allow calculator on the exam, use it. It's 196 equals to x times x, x squared, x times 18, 18x, 18x times x, 18x, 18 times 18. If you allow calculator, use calculator, okay? That's 324. Okay. So now we're gonna put it in standard form by moving everything to the left. But before we do, let's combine x squared plus, no, it's 2x squared plus 28x plus 196. Okay, so equals to, what is that? X squared plus what is that? 36. 36x plus 324. Okay. So we'll combine the net. Let's move things to the left. You got 2x squared plus 2x. What is that? What did I do there? What is that? That's 28x. What is that I wrote down? That's 28x, okay? You see, you gotta slow down, man. 28x, sorry. So 28x plus 196 minus x squared minus 36x minus 324 is equals to 0. So we'll have to simplify things. That and that, you get x squared, okay? Okay, and that. You see that, right? Yeah, so you do like term with like term, okay? Okay, so you get, that's a negative 8x. Alright. And then you do, what else do you do there? You do, let me see, you do that, those two. Okay? It's 324 minus 196. You get 128, negative 128, and this equals to 0. That's what we got. Once you get this, you have to figure out the way you want to solve it, man. It's up to you, right? The way you solve it is up to you. Okay? Choose whichever method you're comfortable with to factor. You gotta factor. You gotta get the factor that out. Now, I like to use this method here. You put x here, put x here. And then what are the factors of 128? That's all you gotta worry about. The factors are 128, okay? Get the factors and eyeball them, see which one will help you to resolve the problem, okay? You know, the factors are 128. You know, you have it, usually there's 1 times 128. 1 times 128. Of course, that won't work. There's 2 times 64. That won't work. There's 4 times 32. I know that won't work. There is 8 times 16. So this won't work. No matter what you do, they won't work. That won't work. That won't work. Because that got high number. It won't work. I think this one, let's say, think about it. You put one of them negative. Let's put this one negative. You multiply them, you get that. If you add them, you get that. You see that, right? That's how you do this stuff. So you put 8, negative 16. Right here alone, I know this will work. That won't work. But let's go through the process, okay? But if you're in an exam situation, you don't have time, just use that one. You'll get it right. Okay, so we'll say 8 plus 8, x plus 8 times x minus 16 is equals to 0. X plus 8 is equals to 0, or x minus 16 is equals to 0. This is the formality. I know that x will be negative 8, which won't work because distance can't be negative, man. Or x is equals to 16. So this will work. So once we get that, we'll go to the stipulations at the beginning. What was stipulated? Yes, what was stipulated right here. Not banker, okay, has x. The distance from, let me see. Not banker, the distance from the cross section, okay. I mean from the intersection is x. So the north banker, the car that is heading north, got 16. Distance, what is that? Is it in feet? It's 16 miles. 16 miles from the intersection, okay? And then they send the car that is heading north, x plus 14. I'm sorry, car that are heading east. Car heading east is x plus 14. So that means 16 plus 14. So that's what is that? 30. That's 30 miles, okay? That car is 30 miles, alright? You see what we're doing, right? Now, 30 miles from the intersection, right? And then the other thing, what is that? The hypotenuse, that's distance between them. Distance between them, okay, between the two cars. Distance between them, it says, is x plus 18. X plus 18. So that's 30 plus 18. So that's equals to 48 miles. That's the distance between them. So this is very, very interesting. You can see this in real life, man. But I don't know how one person may cheat. One mile further, I think what they say one mile further is, I don't know how you can travel mile. You gotta know the mile per hour, But it's okay. That's what they give us. So that's what we got there. What did I do? That's 30 miles. 20. Yeah, that's 30 miles, right? Did I make mistake? Okay, x plus, if x is 16, what is that? X is 16, and then x plus that is 16. Is that x plus 18? What the hell did I do? Hang on, let's go back. Oh, yeah, sorry. What did I do? Yeah, I did it right. Yeah, x plus 18, right? And the other one is x plus 14. That's 30 miles. Oh, I made a mistake. Not 30. Sorry. I made a mistake. This is not 30. This is x. X is 16, okay? Sorry. I said, what the hell? X plus 16, and that's, what is that? That's 30, okay. That's 34 miles. You see that, right? Sorry about that. So what you're looking for is that, that, and that. Okay, sorry about that. What happened, I used this one added to, that's not x. That's x plus 4. Okay, but I corrected it, so we'll move on to the next problem. Don't worry about that. Okay. That's what you get when you're going too fast. Let's look at this one. You see, let's not read it first. Look at the ladder. The ladder is put to the wall next to the window. This is some kind of common problem in physics. They say a ladder is leaning to the next to the building, and you gotta find the angle. Okay, but let's read it. A ladder is leaning against a building. The distance from the bottom of the ladder to the building is 4 foot less than the length of the ladder. You see that? They're playing with words again. How high up the side of the building is the top of the ladder if that distance is 4 feet less than the length of the ladder? You see, this is they're playing with a bunch of mathematical operations, okay? So let's break this stuff down. The diagram even showed you something. Look at the distance between the ladder and the wall, x minus 4, okay? And they say this angle is 90 degrees. That gives you a hint. Pythagorean Theorem gonna be involved. Okay. This distance here from the top where the ladder ends on top to the ground, that is giving you from the problem. We're gonna decode that in a minute. They say this distance here is x. That's what they say. But let's find out what they're doing, and that's the length of the ladder too. But let's see what let's go into the statement. See what they say. A ladder is leaning against the building. Okay, fine. The distance from the bottom of the ladder to the building is 4. This is 4 less than the length of the ladder. Okay. The distance from the bottom of the ladder to the building is 4 feet less than the length of the ladder. What the hell? That doesn't make sense. The distance from the bottom of the ladder to the building. Oh, they're talking about this distance here. Wait a minute. The distance from the bottom of the ladder to the building. Bottom of the ladder. Oh, right here to the building. Right here. Is x. Is 4 less than the length of the ladder. Okay. Okay, so what that tells you, that's the first cue there. It's less than the length of the ladder. You say let x be length of the ladder, okay? Length of ladder. See, because you take the cue from there. Length of ladder, okay? Alright, if that's the case, then they say the distance from the bottom of the ladder to the building is 4 less than the distance of the ladder. So this distance, they gave it distance from the ladder to the building. Okay, they gave it to you as x. Is 4 less than the length of the ladder. Right there, see? This is distance from ladder to building, okay? Okay, that's this distance here, right there. Okay, they say it's already giving you right there. It's this distance, x. Okay, and then what else did they give us? Okay, say how high up the side of the building is the top of the ladder. If that distance is too less than the length of the, see again they're playing with the length of the ladder again. See, first they play with the length of the ladder. So they say how high up the side of the building is the top of the ladder. They want to know this height right here. Sorry, that didn't mess me up. If you hold it down, it turns into something. They want to know this length. Well, that's what they're talking about now. How high up that's what they want. If that distance is too less than the length of the ladder. In other words, this distance here is too less than the length of, which means the length of the ladder, that we already said that here. Okay, we already said that here. So x -2, right there. 2 less than the length. Okay. So this is a Pythagorean situation. We'll have that, but here this is 90 degrees. We know that this one here. So that is the length of the ladder. That's what we're looking for. So based on what we'll have is x. Based on what we'll have, we say x squared. Hypotenuse is x. That's what it says here. X squared plus. So this and that. Actually, no. Sorry. You gotta be careful. This is one leg. This is one leg. This is the second leg right here. Okay, so we'll have x minus 4 squared plus x minus 2 squared is equals to x squared. You see that right there? I mean, that's how they wrote the problem. Okay, so basically what that means, expand it plus x, x minus 2, I gotta slow down, times x minus 2 is equals to x squared. You see that? I just expand it like that. That way I don't make mistake. You start from, you gotta remove all the brackets. Start from the left. X times x, you get x squared. X times minus 4, you get minus 4x. Minus 4 times x, you get another minus 4x. Minus 4 times minus 4, you get, what is that, 16, okay? You do the same thing on the other side. X times x, you get x squared. X times -2, you get -2x. -2 times x, you get -2x again. Negative 2 times negative 2, you get 4. Positive 4 is equals to x squared, okay, on the other side. Now you gotta combine that, and combine that and that. So what do we get? We get 2x squared negative is 8, sorry, 8x. Let me clean that up, man. See, when I go fast is when I make mistakes, but if I go slowly, I do okay. 8x, you see? Okay. Let me see. Plus 16. What did I do? Plus. What is that? Oh, it's negative. Okay. Negative 4x plus 4 is equals to x squared. There's still more stuff to combine. That's okay now. We're gonna combine that and that, and then that and that. So that's 2x squared. What is that? Negative 12x. Okay. Yeah. 16 and 4 is positive 20, right? You see that, right? Equals to x squared. We'll move x squared to the other side. That way we can have the standard form. We'll have 2x squared minus x squared negative 12x plus 20 is equals to 0. We'll simplify. No, it cannot be 2x because we're subtracting one of them. Become x squared minus 12x plus 20 is equals to 0. So this is in a standard form. Once you get it into the standard form, right? Like I always say, use whatever you want. There are different methods available to you to use. Use it any way you want and solve the problem. As long as you get the problem right. You know, what method you use really doesn't matter. You use whatever you're comfortable with. So I'm going to use what I think is a little bit, I'm comfortable with. I can do the other rest, but this is a little faster for me. So you're looking for, this is x here. So the situation will have 20. What are the multiples of 20? At least I can think of 1 times 20, okay? I can think of 2 times 10. Okay, see that, right? 2 times 10 wouldn't help us. I can think of 4 times. Is that 4 times 5? Hang on a minute. Before I jump there, let's do. What is this? That's actually, I was in the right direction. 4 times 5. 4 times 5 is 20. Okay. I think this one will work. This won't work, that won't work. I tell you why I think that will work. Okay. So this is, we haven't seen this kind of stuff for a long time. Notice that we're looking for positive 20. But here we're looking for negative 12. It's okay. Watch this. If I put 4 here, no, sorry. I'm using the wrong one. If I put 2 here and 10 here, make them both negative. Negative 10 times negative 2 is positive 20. You see that, right? That's what is here. And then negative 10 plus negative 2, you get negative 12. You see that, right? So sometimes you have to be careful. Look carefully. You'll see the solution. Based on what I know, both of them will work. I don't know which one do you use. Both of them is gonna work. I'll show you. So you get x negative 2 times x negative 10 is equals to 0. X negative 2 is equals to 0, or x negative 10 is equals to 0. Okay, so you say x equals to 2 or x equals to 10. You see? So we got 2 possible solutions. So how do we eliminate one? One of them cannot be true. We'll go back to the thing. because you gotta look at the stipulations you did. You have this one here. This is from ground to the top to where the ladder ends, okay? You got that one here and you got another one here. Okay, so let's see, the one will work and the one won't work, okay? You got, let me see, x minus, you got x minus 2 is one stipulation, and you got x is another, let me remove this, x is another stipulation, and then you have another stipulation is x minus 4. Oh, sorry, oh Lord, it's x minus 4. X minus 4, see that these are the three stipulations we'll have, right? And these are all distances, okay? Now, suppose we'll try x equals to 2. If we try x equals to 2, okay, so this will be 2, this will be 0, this will be negative 2. So you see, this won't work. You can't have negative distance and you can't have 0 distance, okay? So let's say, see, sometimes you have a situation like this. If we try 10, we got 10 here. We got 10 minus 2 is 8. 10 minus 4 is 6. So this will work. That one won't work. This won't work, but that will work. That's our solution there. So I'm glad we'll run into this, because that will teach you something. Because if you're in the exam, you can use, you gotta find one that makes sense. X equals to 2 doesn't make sense. Okay? So, based on all that, based on all what I just said, right, you gotta be very, very careful. You can spend all the time, get the problem right, but then in interpretation you mess up. So I'm giving you, this is the top, from ground to the top, okay? Ground to top, that's this distance here. Ground to top right here is that, okay? And then from the ladder to the building is x negative s minus, you see here, ground to the building, that's where the ladder is leaning in the building, right? Well, if you go from right here, it's this one, ground to the building is negative, right there, 6. And then the ladder, the length of the ladder from here to here, is that it? Hang on a minute. What is x minus 2? Yeah, x minus 2 is that. X minus, this time from the ladder to the building. Yes, this time from the ladder. I'm sorry, this time from, what the hell? Yeah, what is x? Oh, okay, yeah. And then see, that one is distance from the ladder to the building. Yes, is 6 feet. They're all in feet or inches. Let me see. Yeah. So that's 6 feet here, and that's 8 feet here, and that's 10 feet here, okay? So that's what we're looking for. So we'll leave it there, man. We'll go to the next problem. That way we don't waste too much time, because I want to finish this quick. Okay, this is the next problem. It says a lot has the shape of a right triangle with one leg 2 meters longer than the other. The hypotenuse is 2 meters less than towards the length of the shorter leg. Find the length of the shorter leg. Okay, you see, again, if you pay attention to this, they're always doing the same thing. Okay, you see, they draw it there. This is the triangle, this is the lot, and this angle here is when they say right triangle is 90 degrees, okay? Then you know we're in a situation of Pythagorean Theorem, okay? But notice something though. Even though they're giving us the two legs, leg here, but we can find it ourselves by reading what they say. It says a lot has the shape of a right angle with one leg longer than the other. So there's a longer leg. The longer leg is compared to one that is shorter, okay? One leg longer than the other. The other must be shorter leg. So what we say let let x be shorter leg, okay? Shorter leg. So that's that one there. That's shorter leg there. We say let x be that. Based on what they're saying in the problem, they say then the longer leg, they say one leg is 2 meters longer than the shorter one. They don't say the shorter one there, but that's what they're saying. So the other one is 2 meters. I mean 2 meters longer. So this is the longer leg, okay? You see that, right? Make sure you understand it. This is longer. So you read that, you interpret it the right way, that way you don't make a mistake. This is longer leg, that's shorter leg. Okay, then again, hypotenuse is 2 meters less than towards the length of the shorter leg. You see, now they use the word shorter leg. See, they do that on purpose, because see, they're comparing the longer leg to the shorter leg, and then they're comparing the hypotenuse right here to the shorter leg. So they compare this to that, they compare this to that. They have to do it that way. They ain't got no other way to do it. So that's why you gotta understand that. Okay, so the hypotenuse is what? It's a 2 meters less than twice the length of the shorter leg. So hypotenuse 2 times the shorter leg. 2 meters less than twice the length of the shorter leg. 2 meters less, that's 2 like that. 2 meters less than twice the shorter leg, and then you subtract 2. That's a hypotenuse right there. So you gotta read this problem right until you understand it. So basically this is 2x like that. So once you see this, we are in the Pythagorean situation, right? So you say x squared plus x plus 2 squared is equals to 2x minus 2 squared. You know, so if you keep your eyes on the board, this stuff is it's English, man. You just break it down. Alright, that's what they gave us right there. I like to expand it like this before I start. If I don't, I can do it in my head, but then I may confuse you. Expand it like that. That way you don't make mistakes. It's okay. It take a little time, but and so what? Minus 2. And then you start expanding it, okay? X times x, you get x squared. X times 2, you get 2x. 2 times x, you get 2x. 2 times 2, you get 4. Is equals to, you keep expanding. 2x times 2x, you get 4x squared. 2x times 2, you get negative 2. I'm sorry, you get negative 4x. Negative 2x times 2x, you get another negative 4x. Negative 2 times negative 2, you get positive 4. So let's simplify first. You gotta combine that, and combine that. So let's do it. 2x squared plus 4x plus 4 is equals to 4x squared minus 8x plus 4. Okay, move the thing on the right to the left. You know, just keep doing it. You don't want to complicate the situation. 4x plus 4, negative 4x plus positive 8x, negative 4 is equals to 0. We're trying to put it in standard form before we can solve. So what can combine with what? That combined with that, what do you get? You get negative 2x squared. That combines with that, what do you get? You get positive 12x. This combines with that, what do you get? You get 0. You get 0. We usually don't write 0, which disappears. It's meaningless to us, man. Alright, so it's equals to 0. See that, right? Let me make sure I did it right. 4x. Let's see. Where did I get 12x from? Oh, okay. Let me see. 12x, this and that. Okay, so I think I did it right. I think I did it right. So let's move on. Okay. So if you do like that, let's multiply everything with -1. You get 2x squared negative 12x equals to 0. Okay. Okay. So you can factor. This can easily be factored. Factor, say 2x x negative 6 is equals to 0. You see that, right? We've done that before. You say 2x equals to 0 or x negative 6 equals to 0. You see that? You say x equals to 0 or x equals to 6. I'm sorry, what the hell did I do there? I say something, I write something. I think I'm getting tired. X equals to 0 or x equals to 6. I know that x equals to 0 cannot work because you can't have a 0 distance. It makes no sense. It's like say you drove from your house to a grocery store. It's 0 distance. Then you didn't drive because you didn't move. So that won't work. Okay, so that is what we want. Okay, so once we get that, so the length of the shorter leg, remember we listed there, the length of the shorter leg, this is 6. If that's 6, then the length of the longer leg, 6 plus 2 is 8. They are in a meter. This is meter, this is meter, okay? And then the length of the hypotenuse is 2x. What is 2x? 12. It's 12 minus 2, which is 10 meter. So that's what is going on there. You see it, right? We'll knock that one out. So we're done with that. We'll move on. Okay, here is the next problem. The next set of 4 problems I have for you, they are like physics. All of them are, even the one we just finished, you will see something like that in physics. Where, like in physics, the other problem we just solved, it's like that. You have right angle, they can have like that. They say they put a boulder here, it rolls down. So you get situation like that in physics. But what we have now is a projectile. Projectile can be anything. It can be a phone dropped from a height. It can be something you stand up, you shoot something. You standing up, you shoot your gun up straight in the sky, or you hit a football, right? It goes up, not all the way up, but it goes and then it falls down. Let me draw each thing. So you stand here, you standing here. That's you standing here. You shoot a gun straight up. That's one thing that could happen. Then the bullet will go up, but it will fall down. Okay, that's one situation. Okay. Now, what of this situation whereby there's a tower. There's a tower here. You standing here. Okay. You drop something, like you drop your phone or a stone. It falls down. These are situations you see in physics, man. So we can solve it algebraically. That's what is going on here. Okay, so you could be somebody could be. You can also throw a football. Let's say you're standing right here. You're standing right here. Your leg right there. Yeah, that's you. That's your big head right there. And you hit a football. You hit it. Boom. The football will go down and then it will fall down. You will take that pattern and then it will fall down. See that? So that's a situation in physics. They want to know from you to here what distance did the ball travel, and what is the highest height he went. So this is the situation you can solve with physics, but we can also solve it algebraically. You see that, right? Let me see if I can think of something. Yeah, there's another. Well, you start somewhere, you drop something, drop your phone. I already said that. They usually try to model problem that algebraically. That's the next 4 problems we'll have. This is the first one here. Problem number 22. Say if an object is projected from a height of 48 feet with an initial velocity of 32 feet per second. Its height h is in feet after t seconds is given by that. So you see a bunch of stuff like this in physics. After how many seconds is the height 64 feet? Let h equals to 64 and solve. You see? It says after how many seconds is the height 60? The same thing. Right? Let h equals to 60 and solve. After how many seconds does the object hit the ground? When the object hits the ground, h is equals to 0. You see that? When it reaches the ground, h is equals to 0. Now be careful. I will explain all this to you. Let's say you're in like that. Okay? Based on what they say, initial velocity, you fire up, and then it hits the ground. See, when it hits the ground, x is what? Because this is x as it. X is well, actually it's y. Let me think now. Something is 0. Let me not confuse you. It says h. Well, the height is 0. Sorry. They call it the height because it goes up and then it comes down. So the height is 0. This is the ground. Okay? Okay, so the only one of two solutions from Percy is appropriate here. Why? Okay, so let's solve this problem. I'm trying to explain to you the situations you can see with projectors. They call projectiles. If you hit the ball becomes a projectile. If a car is traveling, you throw something out of the car, that's also called a projectile. In these days, they have a lot of angry drivers. They can take something and throw at the other guy in the car. That's a projectile too. If you throw something on the window, that's a projectile. You throw it up, a projectile. You take a gun and shoot bullet up, that bullet is a projectile. You shoot it straight, it's a projectile. Okay, so let's look at this problem carefully. Okay, so the thing is, they already given you the model. They said the model, the height is from a height of that. The object is raised from a height of that. The initial velocity is that. The height is given by that. It's in t seconds. The t is in seconds. So basically they give you, they give you that. Let me clean that up. I don't want to write with, right? They give you h is equals to negative 16t squared plus 32t plus 48. You notice they said a height of 20. See that's 48 right there. And the velocity is that. That's that right there. And the height is that. The time is t. Okay, so the A, they say, after how many seconds is the height 64 feet? You see, it gave you a hint. Take h equals, because you see, this is a height. So if you take h equals to 64, then you get 64 is equals to negative 16t squared plus 32t plus 48. You see that? Then you gotta solve that. That's the same thing we've been doing. So you write this in standard form. So let's do that. Okay. Let's move everything on the right hand side back to the left side. Okay. Then we get 16t squared and negative 32t negative 48 plus 64. You see that, right? Equals to 0. Okay, you simplify that because you gotta combine these two. You see what we're doing, right? Okay, when you simplify, you get that. All right. So notice what is going on. You can just divide the whole thing with 16. You see that, right? You can divide it with 16 without getting any fraction. Divide the whole thing with 16, you get t squared minus 2t plus 1 is equals to 0. You see that, right? So that way we don't have to work with big numbers. So notice that you can solve it any way you want. It's in standard form now. Solve it any way you want. I'm gonna use the same method I use right there. Okay, so of course, what are the multiples of 1? Multiples of 1 gotta be 1, man. T, sorry. Instead of x, we're using t, so it doesn't make any difference. T is in time. So notice that, instead of x, you use t, because t is in time in physics. Or this kind of problem, t is time, okay? Okay, so 1 times 1 is 1. Alright, but how do you get negative 2? You do that, like that. Negative 1 times negative 1 is positive 1. You add them, you get negative 2. You see that, right? So here we go. So it becomes t negative 1 times t negative 1 is equals to 0. It becomes t is equals to 1 twice. You see that t equals to 1 2 times. Okay. You see that, right? So we don't need the 2 times. We take once. T is equals to 1. That's all we need, okay? Another way you can see that, yeah, that's all we need, man. I mean, we don't need it twice. One of them is enough, okay? So the height of the object, what they want, you got t. The height of the object will be, you got t equals to 1. Let me see. Hang on a minute. Let me see if I can. All right. Actually, t is seconds. So when the object reaches, see the question, after how many seconds is the height? 64. So when t is equals to 1 second, the object will reach 64 feet. That's feet, right? So that's what they want. Okay, so let's move on to B. Okay, so what do they want in B? Say B, after how many seconds is the height? 60 feet. Okay, so you just set h equals to 60. That's all, like we did it before. So you set h equals to 60. You get 60. Let me see. 60 is equals to, what is that? Negative 16t squared. All right. Positive 32t. Okay. And positive 48. That's all. We'll solve that like we did before. Okay, what I'm gonna do, I'm gonna just move everything, move 60 to the right to put it in standard form. We get 0 equals to negative 16t squared plus 32t plus 48 negative 60. You see that, right? 0 is equals to negative 16t squared plus 32t. What is that? Negative 12. You see that, right? Yeah, negative 12. Okay, so when we get here, let me multiply everything by negative 1 because I want to put this in. We want to put it in standard form. 0 is equals to 16t squared negative 32t plus 12. Okay, we'll move things around. We didn't change anything. 16t squared negative 32t plus 12 is equals to 0. Okay, so we're gonna factor this. Factor it any way you like. Okay, factor it any way you like. Look at that big number. You have 12 at the third term. Look at the big number over there in the middle, 32t. And then notice that t squared has a 16. So you gotta be careful, man. So when you're working with stuff like this, you gotta be careful. If you're not careful, you're gonna end up in a loop. So I'm gonna leave it the way it is. I don't want to multiply, divide anything, because I tried doing that before. I just run into a lot of problems. So let's do it like this. What is this? 8t times 2t will give you, will give you 16. It will give you 16t squared, right? Okay. Now Now we'll have to work with this. What are the factors of this? There are different factors. I think 4 times 3. What is that? Is that 4 times 3 is 12? Is that 12? Yeah, 4 times 3 is 12. Okay. Yeah, I think I'm getting tired. 4 times 3 is 12. So where do we put 4? Where do we put 3? That way we get that, negative that. And don't forget, negative 4 times negative 3 will still give us positive 12. So if we put, let me see, we want 20, just 24. If we put 3 here, that will be 24. Negative 24 plus negative 8, yeah? So it's suppose I put negative 3 here and put negative 4 here. Okay? What we will get? We'll get over here, we'll get negative 8t, okay? Over here, we'll get negative 24t. If we add it, what do we get? We'll get negative 32t. See that, right? So this will work. You see that? I don't know if you see what I'm doing. Yeah, this will work. I don't want to waste too much time. 3 times 8 is 24, negative 24. When you add those, it will become negative 32. You see that, right? Negative 32. That's what we'll have here. So that will work. So we'll work with that. I don't want to, I'm getting tired. Let's move on. So you get that, you get that. Okay, so now I ran out of space. So I'm going to have to borrow space from the left or from the right. Let's do it from the left, okay? Let's do it here. So we'll have 8t, negative 4, and what is that? 2t, negative 3, all equals to 0. Say 8t, negative 4 equals to 0, or 2t, negative 3 equals to 0. So we'll do 8t equals to 4, t equals to 4 over 8, or 2t equals to 3, t equals to 3 over 2. So those are the stuff we'll have there. So which one is correct, man? It's a matter of, we got those. Oh, actually, let's simplify. This is t equals to 1 over 2, right? Yeah. So you can simplify the other side a little. So that's what the height of the object is after. Okay. So the height is 60, right? 60 feet. Okay. Well, I guess those are the two T's. We're going to say, the height of object at h is equals to 60. What did they say? H equals to 60. Yeah, h equals to, the height is 60 feet. Either at t equals to 3 over 2 or t equals to 1 over 2. That's all. So we'll move on to the next one. I ran out of space, man. So we'll still gotta do C and D. Okay. Just give me a minute. We'll find some space. Okay. Notice that C says after how many seconds does the object hit the ground? Well, when object hits the ground, the distance traveled is 0, right? So h is 0. So all you gotta do, set h equals to 0. H equals to 0 and solve. You set h equal, that means negative 16t squared plus 32t t plus 48 is equals to 0. Okay, that's all that is saying, man. So you solve that. Okay, so let's divide everything by, let me see, divide everything by, suppose we'll do negative 16. What do you get? Okay, that way we'll remove that that thing there. So you get t squared negative, what is that? Negative 2t negative, what is that? Okay, that's negative 3 is equals to 0, right? Okay, so you see, we gotta solve that, man. I think we'll solve something like that before. So you go like that, you go t 2 times 1. Okay, it's 3 times 1. That's all you can get, right? And you make that negative. If you multiply them, you get negative 3. And then if you add them, you get negative 2. So with that, you get t, okay, t negative 3 times t plus 1 is equals to 0. So t equals to 0, or t equals to 0. T is equals to 3, or t is equals to negative 1. You see that, right? You know, so in a situation like this, this will not work. There's nothing like negative seconds. Okay, so the object will hit the ground when you say when, sorry, I'm trying to go too fast, you know, because I'm getting tired. You say when t equals to 3, the object, the object, you know, hits the ground. Okay. Okay, so we're done with that. Let's do number D. What does number D say? Number D says only one of the two solutions from part C is appropriate here. Why? Oh, okay. Because you can't have negative seconds. D say why? Why is t equals to negative 1 not possible? You know, basically that's what that is asking. And I'm saying you cannot have you can't have a negative second. Okay, it's not possible. You can't have a negative second in time. Okay, there's nothing like negative 1 or negative 10 when you talk about time. You see, it doesn't make any sense to say, you know, you can't have a negative time. So that's it right there, man. Okay, here is the next problem. I don't want to run out of space, so I'm going to split it up like that. It says if an object is projected upward from ground level with an initial velocity of 64 feet per second, its height is h is in feet. What is that? In feet. T seconds later is given by that. They give you by that. Okay. So here are the questions. So basically, the object is thrown up, you know, upward, and then after a while, you know, it's gonna go up, and then it will start coming down. Then it will hit the ground. Okay. So they have various questions of when the object in various positions. Okay, and the time it reaches the ground, time it reaches the top. That's all they're saying, man. You understand, right? So you throw an object up. You will get to a maximum height, it will start falling down. That's what is going on here. They model it with that equation there. And they say after how many seconds is the height? 48 feet. In other words, when will it reach 48 feet? So let's do that. And we'll try to conserve space. I'm sorry, I don't want to write with red. Let's clear that out. We're going to write with like that. Okay. So when the height reaches 48, it means h is equals to 48. And then we say 48 is equals to negative 16t squared plus 64t. That's all. So we're going to solve that. We put it in standard form. We get 0 is equals to 16t squared plus 64t. That's negative 48. So to put it in proper standard form, we multiply by negative 1. We get 0 is equals to 16t squared negative 64t plus 48. You see that, right? Okay. We can shift things around, if you don't like it, if you can see it clearly like that. 64, we didn't change anything. We just move the 0 the other side and bring everything to the left. 48 is equals to 0. Okay, you see that, right? So we're going to factor that. Yeah, we're going to factor that, man. We'll have to try to factor that anyway, any method we want, okay? Listen, let's divide everything with 16. We'll get t squared. Let me see, that is 2t plus 3 equals to 0. Yeah, you see that, right? No, actually, no, that's a mistake. That's 4. I'm sorry. Yeah, that's 4 right here. I made a mistake there. Clear that. I put 4. You can't have 3 here and then have 2 there. Okay, so we're gonna try to what do you call factor that. Okay, so if we have 3 here and we have 1 here, you multiply them, you get 3. So let's do negative. You multiply both of them, you still get 3. See, negative, you get positive 3. I'm sorry, it's t. Sorry, t here. So that will solve it, because when you add them, you get negative 4. So this will solve it. Okay, t negative 3 times t negative 1 is equals to 0. T is equals to 3 or t is equals to 1. That's what you're gonna do when you solve that. So that means when it will reach 48 feet when t is equals to 3 seconds, or when t is equals to 1 second. You see that, right? That's all that is saying, man. That's all that is saying. I know there's a confusion there. I don't know why you have 2 times, but that's what we got. Okay. Anyway, let's do B. What is B? Let me see. B is here. What does B say? B says the object reaches its maximum height at 2 seconds after it is projected. The maximum height. What is this maximum height? Okay, so they're saying that it reaches. Basically, they want you to find h when t is equals to 2 seconds. That's all. So you put h is equals to. Let me see. What is that? H is equals to negative 16. It's negative 16t squared. What is that? Plus 64t. Okay, when t is equals to 2, you solve. You get h is equal. That will give you maximum height. Negative 16 times 2 squared plus 64 times 2 squared. Okay, what do you get there? You get 2 times 2 times 2 is 4. 4 times 16. what do you get? You get negative 64, okay, plus 64 times 2. You get 128, okay? Okay. Alright, so 128 and minus 64, you get 64. So it would, the maximum height would be 64 feet. It will be 64 feet. That's the maximum height it will reach. 64 feet. You see that? That's all we got. It will be 64 feet. And then what is C? C says, after how many seconds does the object hit the ground? When the object hits the ground, h is equals to 0. So they want you to put that, that's C. H equals to 0 and solve, okay? I thought we did that. Okay, we haven't done that before. H equals to 0. Then we'll have 0 is equals to negative 16t plus 64t. They want you to solve that. Okay, notice that, where did I say t squared? Sorry about that. It's not t squared, it's t. Okay, so notice that we can solve this easily, right? We can pull, if you look at that carefully, you can pull 16 out. So you say 0 is equals to, if you pull 16 out, you get, well, let's rearrange stuff first. Let's rearrange stuff. We can say move it over the other side. We'll say 16t squared negative 64t is equals to 0, okay? Then we'll move 16 out. We get t squared like that, negative, what is that, 2? I think it's 4. 16 divide 64. Yeah, it's gonna give, 16 divided 64, so it won't go 64 divided by 16. Yeah, it's 4. So 4t like that is equals to 0, okay? You see that, right? Okay. Hang on a minute. And then, well, then it becomes t squared minus 4t is equals to 0, okay? And then you can say t negative 4 is equals to 0. You see that, right? So t is equals to 0 or t is equals to 4. So that's what we got there. So when it hits the ground, t can be 0. I think the one t0 won't work, because what is that? That's number C, right? So we'll get t. Yeah, see, t is equals to 0 is when before you throw it up, there's no time. So when it hits the ground, the time is it will go up and come down. It will be that. So disregard that. This is when you throw it up, because before you let it go, before you shoot the stuff, or immediately before you shoot it, t is equals to 0. So we did that right over here. Okay, let's do what is that? That's a BC. Let's do D. These things are long, man. Let's do D. What does this say? Only one of the two solutions from Pythagoras is appropriate. Why? Yeah, because when you hit the object up, it will travel all the way and then it will come down. If you turn your clock on it, when you have a stopwatch on, you will know there's a time going up, there is a time going up, going down. So that would total 4. The one that it says 0 is when it shoots up. So that one is nothing, man. So it represents the time. T is equals to 0 is when you first let it go, okay? that time, so that doesn't count. What counts is t is equals to 4, because it has to travel, that's seconds. It has to travel and then come down, so that's the right t. Alright, so let's go to E. What does E say? After how many seconds is the height 60? Again, we've done something like that. It takes 60 is equals to, you equate that right there. Height is 60, so you say 60 equals to negative 16t plus 64t. You solve for that, that's all. So let me rearrange 60 plus 16t negative 64t is equals to 0. This is the standard form. Actually, let's rearrange it. It's 16t negative 64t plus 60. So this is the standard form. Okay, so this stuff here, we can simplify a little bit more. We'll say, because we don't want to work with big numbers. If you work with big numbers, 2 times that, let's divide it into 2, see what happens. Divide everything into 2. Just give me a minute, let's see. Okay, so let's divide everything by 4. You get 4t here. This is t, 4t squared. Divide 64 by, you divide 64 by 4, right? What do you get? You get 16t. You divide 60 by 4, you get 15. It's equals to 0, okay? Okay, I think we can handle this. So if I put, well, let's do like that, 4t and the t here will give you that. If I put 15 and 1 here, actually let me see, because the let's see, 1 times 15 will give you that. Or you can say, let me see, say 3 times 5. Okay, 3 times 4 is 12. 12 plus 5 is not, is it 16? No. Now suppose I do 5 times 4, 20. Okay, so we can, let's do it this way. Sorry. Yeah, sometimes this can be, if you get confused, you use another method, okay? Let's do it like this. Okay, so suppose we do 3 and 5, all right? If we do 3 and 5, what do we get? 3 and 5, we get let me see, 60 plus what is that, 10t. Yeah, it will work. 10t, see? So basically this is positive, so this has to be negative. See, if we do 2 negative, we will still get positive 15. Okay, then when we multiply out, we get negative 16. So that will work. See, that will work right there. So I think I'm getting tired, but it's okay, because I've been doing this for a long time. So let's do 2t negative 3 times 2t negative 5 is equals to 0, okay? And then you have 2t negative 3 is equals to 0, or 2t negative 5 is equals to 0. You say t here is equals to 3 over 2, or t here is equals to 5 over 2. That's what we got here, man. The height of the object, if the height is 60, then you have either the seconds are either 3 over 2 or 5 over 2. Okay, so that's how you say that, man. So when well, I'm gonna run out of space. We'll leave it like that. I already said it, okay? So I don't want to run out of space. Let's go to, that's E. Let's go to F. We'll go to F. What does it say? What is this physical interpretation of any part y part C has two answers? Okay, well, the object can get up to 60 feet once it gets all the way up, right? And then once it start coming down, right, then the second will change. That's all. That's the only way I can, because you see, it's gonna go up and then it will start coming down. So that will be a difference in the time, okay? It goes all the way up, all the way up, and then you get the maximum. I think is this one, and then once it start coming down, once it starts coming down. Wait a minute. When it gets when it goes there, it gets the maximum. Which one is the maximum though? 5 divided by 2 is a half. I mean 2.5. Sorry. And then 3 divided by 2 is 1.5. Okay. It's kind of coming when it goes all the way up, right? I think you will use this one. Use this one up. Then when it starts coming down, it will use T will be when it start coming down. That's what I was gonna write there. T will be 3/2. You know, because it will go up. Then there will be a fraction of delay before it start coming down. Because it will stop. When it goes up their maximum, it will stop and then it will start coming down. That's when you have that T here. Okay, so I think that's how I interpret that. You know, but anyway, let's go to the next one. Okay, look at the next one. It says a cell phone is dropped off a nature observatory that is 144 feet above the ground. The height h in feet of the cell phone after t seconds is given by that. Alright? After how many seconds does the cell phone hit the ground? I don't know why somebody would drop their phone from up there. Maybe by mistake. You must be crazy. When you're up there, you put your phone in your pocket. You know, but anyway. So this one, they give you a height. Okay, and then they ask after how many seconds does the cell phone hit the ground? Based on what we solved earlier, when it hits the ground, h is 0. A bunch of stuff is 0, man. When does the cell phone hit the ground? Okay, we're looking for seconds. So when it hits the ground, the distance traveled is 0. So basically, what they want you to do in this problem is you set when h is equals to 0, solve for t. That's all. You know, let me write it correctly. When h equals to 0, solve for t. Okay, that's what they're asking you. So you say 0 is equals to negative 16t, because they're looking for seconds. This is a common problem they deal with in physics. You know, you dropped something. You drop something from up somewhere, it comes down. You know, in physics, they're gonna put friction into consideration. Let's say you drop a feather. What do you call it? A feather, or something that is very light. The time it would take to hit the ground, I don't think it's the same time that cell phone will hit the ground. You know, I don't remember the controversy. Well, not the controversy, but the theory. They say in theory both of them will hit the ground at the same time because there is a gravity pulling them down. You know, but that's physics. Now we're doing algebra. So we'll leave that alone. Here we'll solve for t, okay? I'm going to move everything to the left like that. I didn't change anything. If you want, we can multiply by -1 to get 16t squared -144 is equals to 0. Okay, so we can try to factor. We can try to factor that thing out. Okay? We'll try to factor that thing out. we'll factor it out like this. We'll say, let me see. Notice something. There's no sense in factor it out. We divide everything by 16, okay? If you divide everything by 16, you get t squared negative, let me see, negative 9 equals to 0, okay? See, we remember we dealt with something. This is like t squared negative 3 squared, which is the same thing as t negative 3 and t, see, equals to 0. I don't know if you remember that formula. You know, we dealt with that formula before. So it becomes t is equals to 3 or t equals to negative 3. This one won't work. You can't have negative seconds, okay? So what they're asking us is when would the object hit the ground? It will hit the ground in 3 seconds. That's all. That's all that we're solving there, okay? Okay. Let me write it. Object hits the ground in 3 seconds, okay? That's all. So we'll move on to the next one. Okay, so it's similar, almost the same thing. It says a rocket is dropped off a cliff that is 256 feet above a river. The height h in feet of the rocket after t seconds is given by that. After how many seconds does the rocket hit the water? That's when h equals to 0, okay? Again, it's h equals to 0, you solve, that's all. When h equals to 0, you solve, because that's when it hits the water. Basically, they're telling you how many seconds later, okay? They're telling you find the same thing we did above. Find t when h equals to 0, okay? So you say 0 equals to negative 16t squared plus 256, okay? Okay, so we can move things around. Say negative 16t squared plus 256 is equals to 0, okay? Alright, so multiply everything by negative 1. You get 16t squared negative 256 equals to 0. Okay, so you solve that. The question is will 16 go into 256? Yes, it will. So it's t divided by everything by 16, t squared negative 16 is equals to 0. Notice that it's the same pattern from the other problem. So you can write this as t squared negative 4 squared, which is the same thing, equals to 0, which is the same thing as t squared. I'm sorry. What? You can have that t negative 4 times t positive 4. We dealt with this in the past. Whenever you have two things like that, two squares like that, either negative or positive, you should be able to factor it like that. I know that you're gonna have t from here, t equals to 4, and from here you're gonna have t. I'm sorry, I'm going too fast. You're gonna have t equals to, it's gonna be t that or that, t equals to negative 4, but you can't have negative second, that one won't work. So the object will hit water, right? The object will hit water when t is equals to 4 seconds, okay? Okay, 4 seconds. Alright. Another way to say the same thing is, you can say the same thing like this: when h equals to 0, right? That was the original condition right there. When h equals to 0, all right, t will be equals to 4 seconds, okay? Right? That's the same thing. You know, the object will hit water when t equals to 4 seconds. Same thing as saying when h equals to 0, t equals to 4 seconds. I think I will leave it here because we'll move on to something else. Please subscribe to my channel, like and share this video. If you have comments or questions, leave it under this video and then I will get to them, okay? Thanks for coming. I'll see you in the next video. By the way, Happy New Year in advance. Bye.